Ladies and gentlemen, good morning and welcome to the BDA Innovation Day. First, I would like to thank Arabs for these facilities. They're absolutely fabulous, and we're a lot less cramped than we were on our last day when it was based on restoration. Brick earth or clay has been used for thousands of years, and when fired over 950 degrees centigrade becomes a piece of ceramic. And to give you some idea, we had a visit from a delegation to the BDA offices in the building centre from China, and they gave the BDA a book, and within that book there are photographs and samples of products that go back for thousands of years. And the first bricks, for example, were not the shape that we know today. The first bricks were made by boiling clay, because I presume that they'd run out of stones, and they made like stones out of clay, which were just ball shaped, and then they used a lime daub or whatever to build them up to weatherproof. And those are 5,500 years old, and I thought that was really old. And then I spoke to Fernando, and he said yes, but in Iran, the fired clay units were like 11,000 years, 11,000 years old. But looking at this book in China, you can still have samples in their museum. For example, pan tiles are 4,200 years old. Pipes, which they made for water drainage, were tapered, and the small end went into the large end, and they were 3,500 years old. And hollow blocks, which we tend to think of being, quite innovative, were 3,000 years old. Now, the Romans came here 2,000 years ago and brought brickmaking to the UK. I think prior to that we were on daub and wattle. If you listen to some of the people, they'd like us to go back to daub and wattle. So we'll wait and see. So it's no coincidence that archaeologists use ceramic pieces when they do their digs for dating their finds, in that ceramic, well fired, will last forever. Now, modern brick buildings are warm, secure, have low build cost, beautiful, very low maintenance, locally produced, naturally sustainable, and the material is always locally sourced. So nothing comes close to ceramic products for performance. And it is our product of choice. Today, when you see the slides and the presentations, is really exciting, and it's a great program. And I would like you to see ceramic products to their best advantage. Our team, Sarah in particular, have worked really hard to pull this together to make this a really enjoyable day. To start our programme, I would like to introduce Chris Williams, who's the Labour MP for Derby North. And as you can tell from my accent, I've got a Midlands accent. And he's been very much in touch with the clay industry, and bricks in particular, and I'd like him to come up. Thank you.
For that introduction, and it's a great pleasure to be here today. And I mean that most sincerely. I know most people, when they come to any event and address them, they say what a great pleasure it is. But it really is for me, because I am a former bricklayer myself, and when I started out in the building industry, 40 odd years ago now, in the 1970s, I never thought in a million years that I would be opening the event like this. In my capacity as MP for Derby North and a shadow minister. So I'm really pleased to be here today, and I just want to sort of obviously say just a few words by way of sort of introducing the event. In my view, and certainly as far as the Labour opposition is concerned, construction has got to be key to getting the economy growing again. I often say, look, I'm just a simple bricklayer, but it's kind of common sense to me. It's a very labour-intensive industry. I know that from personal experience. When we look at any construction site, there are lots of people beavering away there, bricklayers and many other trades as well. It's a great career for young people as well. It's reasonably well remunerated, and it gives young people, I think, hope if we can give them a chance of a decent future by providing proper training opportunities through decent apprenticeships, the sort of thing that I went through when I was a lad. And obviously, if we can get people back into employment on construction sites, building the homes that people need, as well as other improvements in terms of new schools and so on, then obviously that fulfills a social need, but it clearly helps to grow the economy as well. And I was really pleased to see this document, just was chatting just beforehand, and it's I think just worth repeating some of the stuff containing here over and over again. It kind of sets out the facts very appropriately, I think. We're talking about creating 2.5 million jobs, for example, and growing GDP and so on and so forth. And those sorts of simple facts, I think, are worth repeating over and over again. And my dad actually was in the construction industry himself. He wasn't a bricklayer, he was a plasterer, but he grew up, was born in 1920, grew up through that period, through that Great Depression. But he managed to get a job in construction because in the 1930s, as people will know, probably those students of history, that as a way of trying to get the economy moving again, there was a big investment in construction at that time. And that's why my dad ended up in the construction trade himself and remained in the industry for most of his life, actually, and run his own business for a period of time. But I think in terms of today's event, the BDA's Innovation Day, it is very appropriate, I think, that we're looking at innovative new ways of using traditional materials. I mean, I think those traditional materials are materials that most people actually want to see. I mean, they are aesthetically pleasing, and there's new ways, of course, of using those materials. I mean, bricks aren't always now used for structural purpose, often used as a sort of a cladding material. But having that sort of traditional facade on a building is something that I think lots of people like to see. And we look back and we walk around London and see some of the great brick facades in different parts of the capital, and in every city and town and village around the country. It's great to see, and so there is a huge opportunity there, I think, to bring these traditional materials into the modern world. So it's obviously today is a very apposite in that sense. And of course, and I was reading some of the background material before today. I know that the industry is now looking at the implications in terms of climate change, sustainability responsibilities, in terms of making the materials in the first instance. But of course, the other thing in terms of that whole sustainability agenda, as I think everybody in here will be well aware, but again, I think it's worth repeating the point and making the case out in the wider world, is that bricks are have a very, very long life. I mean, I live in a house which is over 100 years old, and is likely to have at least another 100 years, if not more, life in it. And I don't think you can say the same for some of the modern materials which have been used in the 60s and so on. So that's good to see that whole sustainability agenda is being promoted as well. And I think that's really important as part of the whole issue around promoting bricks as a material of first choice. But in terms of getting the construction industry moving again, clearly we need to do more. I think all governments have failed actually over the last 20, 30 years or so, in terms of actually seeing the investment that's really required in housing. I mean, I know there have been some exceptions, and in some areas, construction is doing okay. But in general, it is an industry which isn't actually anywhere near meeting its potential. And as far as we're concerned, as the Labour opposition, as we're developing our housing prospectus for the next election and beyond, we made it very clear, both through our Shadow Housing Minister, Jack Dromey, and indeed the leader of the Labour Party, Ed Miliband, that housing will be a key plank of our offer at the next election. And one of the things or a number of the things that I would like to see is developing our policy prospectus on, and we're kind of working our way through this now, and we will be starting to put the meat on the bones more, But I think one of the areas where we probably have got housing policy wrong is the way in which subsidy is deployed for social housing and affordable housing. And you can trace this back around about 40 years when the whole rent rebate scheme came into operation, and government ministers at the time, the accepted wisdom was that the issue of housing supply had been dealt with, had been satisfied. It was no longer an issue of supply, and we therefore, the feeling was, needed to find a more flexible way of deploying housing subsidy. So rent rebates were brought into being, and that became housing benefit latterly in, I think it was in the early 1980s. And then we saw the deregulation of the private rented sector, an inevitable increase in rent levels as a consequence of that. And when some of those decisions were being made, and the housing minister at the time, when the deregulation of the private rented sector was going through the House, said that if people can't afford to pay market rents, housing benefit will take the strain. And the problem with that has been that the housing benefit bill has risen exponentially during that period of time. And 20-odd billion pounds a year is going into housing benefit, which is a housing subsidy, let's be clear about that. But we haven't got a great deal to show for it. If we'd have actually used that resource, or a large proportion of that resource, to invest in bricks and mortar, then we would have built a lot more dwellings for people to live in, and there would have been something tangible, I think, for us to see at the end of it, even if there had been a scaling back in the amount of funding that was going to that purpose. So I think the whole issue of housing subsidy is something that we need to look at, and how we can deploy that more effectively in the years ahead. And Shelter have done an excellent report, some of you may have read that, called Bricks or Benefit, and if you haven't read it, I would recommend that you do, because it gives some very cogent arguments around why it's better to be putting government money into subsidising bricks and mortar rather than the housing benefit scheme, although obviously the housing benefit will continue in some form or another. We've obviously got to increase supply. We have a massive housing crisis. It's particularly acute in London, but it is a problem throughout the country. We've recognised that, I think, in the Labour opposition now, and we're very keen to try and address that after the election. That will be both in terms of new build, refurb, and the social housing sector, and also a renaissance in the private rented sector as well. We're looking at new ways in which that might be deployed in a more cost-effective and appropriate way, and meet that kind of social need. We also have to, I think, deal with quality and ensure quality, because some of the properties, I know many moons ago, there was, running out of time now, I see, many moons ago, governments used to vie with each other as to how many houses they could build. If only we could maybe get back to that period of time. But the problem is that, or the problem was, should I say, that the quality of some of the dwellings that was built at that time wasn't that great. So that is an area that I think we need to address as well as dealing with issues around affordability. But I'd conclude by saying the most important thing from my point of view, I guess from your point of view today, is that our ambition, if you like, for housing and construction in general, will hopefully lead to a renaissance in the brick industry, and hopefully provide jobs long into the future, both in terms of the supply chain and for people like I used to be, a bricklayer on construction sites, offering great opportunities for people to earn a decent living and fulfil a social need, because we do have a desperate need for housing in our country. So thanks very much, and enjoy the day.
Thank you, Chris. OK, the BDA would like to welcome Eric Parry from Eric Parry Architects.
Well, good morning, and let me break the ice then on the real stuff, as it were. I think that it was, brick is warm. That's very clear. It's a very disciplined material. I think it's a module. It's unlike stone, which can be cut and shaped and so on. When you're working with brick, you're working with a discipline like you would be if you're a weaver on a loom. There's whatever it is, you have a dimension. That dimension is very, very important. I guess in terms of the amount of brickwork, and I'm sort of moving from that idea of warmth, a product that is transformed out of a kind of sludge ultimately into its modular form. And I'm going my 35 minutes, 30 minutes, and some questions, I hope, is just about a journey, really, from brick through thinking about slightly more artificial materials, if you like, and finishes that are not so, quotes, natural. So I've called this against nature in a very positive way. It's not meant to be a sort of aggressive against nature, but it's a sort of sense of working from things that are natural towards things that are full of artifice and are made by invention, if you like. So I would say one of the first buildings, there's a bit of difference in terms of a bit washed out. The one on the right seems to be a bit better, but the first buildings I was engaged in with brick was a very simple library for Bedford School. And as Andrew Motion, who opened the library, said, you know, a library is a very it's a dangerous place. It's a place of ideas. It's a place where you kind of discover yourself in a way through the books and the wisdom that is stored. And to represent that, this is a school with very with a Victorian building that's very institutional, very vertical. I wanted to work with this horizontality. So the books are held in a volume behind this wall, and the wall is set on top of posts and sections of wall on a lintel, and I wanted it to be made of brick. It had to be very economical. It was a very economical building, but I definitely didn't want it to be a sort of skin that wouldn't have, and I really believe this is true, that with material, you know, you can really feel when it's doing its job. The job here is not to hold, it holds up the roof, but is not to hold the entire building up. But what I wanted to do was to achieve a wall without movement joints in it. So it's about 70 meters long. And we worked with the BRE to establish that using a lime mortar, and it's a full brick width, so it's not a skin in that respect, we could achieve this continuous line of brickwork without any movement joint, and that was the goal. I mean, it sounds it's easy to compromise and things. The bricklayers loved it. It's a wall that has only standard semi-standard curved bricks, so that there was one radius, and that set the wall. And then it was the bond, and it was having worked with the local contractor, Neville's great contractor, on those tests with the BRE. We were really thrilled to find that we could do it. And for me, that's the joy of going back to that building. Incredibly low energy building. And whilst very economical, it just has this great bit of brickwork, which is lovely, and I take a huge pride in the craftsmanship of this, the technical craftsmanship, with Adams, Cara, Taylor as our engineers, and not persuading. You know, one forgets that the art of kind of being a designer and part of a design team is something we're not really talked about, which is to encourage encourage a dialogue with the people who make buildings in order to go that extra mile. That's what makes the difference to a building. It's the crafting that goes into it that's absolutely key. Now this is I've placed this horizontally, just so you don't get it's particular characteristic, which is a vertical wall of polychromatic brickwork. And actually, this journey that I'm going to show you today, and this is not by way of I haven't been given a backhander. We've done quite a lot of work with Shores of Darwin. We work with other ceramic producers, but Shores have been a partner in an exploration. And it began here, Wimbledon School of Art, a building that has a brick box that contains, like the library, a rather innovative space for art and exploration of an acoustically sealed space. And then it has a little courtyard, and this wall lies at the end of the courtyard. And working with an artist, John Mitchell, who used to teach at the School of Art, and it's a fantastic School of Art, actually, Wimbledon. Great figures like Prunella Clough and many others who have gone through it and taught generations of students. So John had an interest in forms that interlinked, and it does look like a bit of a kind of carpet when it's put on its side here. I remember we had so the idea was to have what he wanted was 7 shades of blue and 7 shades of red that alternated in terms of their density, the darkest to the light and vice versa, and it gives a very three-dimensional effect. So this was taking a standard brick, and Shores then glazed it. And I remember we wanted a tight joint, so we were very clear, actually, but somehow this entire wall exists, is what I'm going to say, twice, because the first time it arrived, we'd insisted on it being an imperial size so we could reduce the joint. And it all came as a metric unit, and of course we were awash with joints. So it all had to be done again. And in the end is a very beautiful presence. But it's the first use for me of ceramic. And people say, well, ceramic, does it last? Does a glazed brick last? And I say, just in the same way, go to the British Museum and go and see the Babylonian use of glazed bricks, or go anywhere into the Baltic and into those Hanseatic cities that are so dependent on brick, and you find these wonderful glazes from the kind of 13th and 14th century. And so the answer is it's incredibly durable, obviously. The question is where you should use it and how you should use it, probably. So here we are with a module, but the next project I'm going to show you is one that is not this one, but it follows, is about the use of ceramic not as the module, but as something that's slightly more sculptural, perhaps. But it starts, the end of this brief description of the use of ceramic, again with an artist, Richard Deacon. I will come back to the origins of the thinking of the use of ceramic. And it starts with this building, which is a stone building. And it's very interesting. Stone, if you... working in London, London is a city of Portland stone. Now, if you go to the quarries in Portland, one thinks of Portland stone as a homogeneous material. But if you then are talking to the masons from Portland, and they go to a building, there's this fantastic palette of difference. They'll point out that that's a bed of a particular material from a particular quarry, and it's astoundingly varied, but it's natural. It's what you find. You can finish it in different ways, but a roach or a whitbed is going to have a particular character. And on this building, which is a load-bearing stone building, as a good friend of mine called it, high-tech Stone Age, because there's no steel frame behind the building. It is what you see. All these stone piers are beautifully made in 4 pieces of stone, shipped to site just in time, and it's stacked up. And I wanted to work in a particular area of the facade here with a sculpture. And the proposal for the sculpture was this, by Richard Deacon, who I think is a brilliant artist. what he wanted to do, I was aware of his work in ceramics, and he had proposed a stainless steel chain, almost like a bead, you know, a necklace, with cylinders of ceramic beads. These would have been polychromatic, and this is just the maquette, that wove in around the massiveness of the stone building. And for whatever reason, between not being quite firm enough over planning and the client, it didn't happen. So it was a sort of, for me, a great loss, and I went on thinking about ceramic. Having his ceramics at this period were related to a particular work that he was doing in a studio in Cologne, and with a particular fabricator who could make these beautiful forms, wonderful viscous glazes. So at the same time, I was fighting the cause of, you know, architecture and various other projects, and the next one was this one in Bath, and it's a happy ending to a very difficult story, I would say. But it's a building that is a neoclassical front at the end of a great street called Great Pulteney Street, which is about 600 meters long. It's a set piece for history movies and so on. And it was the entrance to a pleasure garden, and the pleasure garden, it's the only extant pleasure garden in the country. Actually, it's amazing. It just stands there. It got cut off because this was a sort of gaming house, and you went through, and on the back of the building, I'm concentrating on the materials, but just for a moment, on the back of the building, as you went through this, you came out the other side from this classical, very strict street, into a space with fireworks, with a band above your head, with supper boxes. You know, it's a kind of pick-up joint, but it's a place for the community. It had a labyrinth, it had a hermit, it had a dwarf, it had swings. It was a fantastic, different world. The garden as somewhere to really to take pleasure, literally, for leisure. And that had all got washed away a bit, because this had turned into a museum, and the museum owners had put a wall around the back of it, so it disconnected from the garden. Now, the museum in its current guise, it would be madness to take a museum out of a garden context. So the argument was to take a staircase that had been built on axis in the Grade 1 listed building, move it, and then create an extension. But the extension needed to be, in my mind, open to the garden, different. It's a Janus-headed proposition, if you like, and always was. And so whereas with stone, you start with the lightest elements, these urns that are the silhouette against the sky, and then you gather weight as you go through till you get to the rusticated base. That's what a rusticated base is about, gathering the weight. On the back, I wanted to invert that, to have a place for the community, a cafe, like those supper boxes in the garden, so as much transparency as possible at the bottom, and then to contain some of the treasures from what is a very important collection, because it's completely intact, of a man called Sir William Holborn. And then what any gallery depends upon, which is a place for temporary exhibitions. That's how they make their kind of mark and earn funds. So that meant having a blind wall. The heaviest bit of my proposition was on top, and the lightest bit was below. So the question was how to use it, and why not? Of course, the cry went out, because this is a World Heritage Site, Bath, listed garden, listed building. Why not? Why on earth are you not using Bath stone? And the reason for me was simple, that that Bath stone required, and if it was in a street, I would do that. I've done plenty of well-mannered buildings in streets, but here I wanted it to levitate, to be magical, to have that sort of lightness. And if you start, I do not ever want to find myself working with stone in a way that sort of, it's like bathroom tiling and it's floating. So I couldn't. That was my argument. It just didn't work for the architectural concept. So these are the initial sketches of how to start to think about just as the front is, a 3-staged building. These are 2 levels in here, and then the big gallery space on top and the glass below within the garden. And it's a sort of shadowed world. It gets direct south light on the other side. Here, it's a wonderful world. I imagine the world of theatre, of Shakespearean lighter garden settings like Twelfth Night or whatever, A Midsummer Night's Dream, and the sense of, and now it's very washed out, I'm sorry, but the sense then of how to achieve that was to find a material, so glass at the bottom, and as light as possible, so as like a veil of glass, to try and set the environmental glass behind a veil. So this is what we call a triple skin. Then to have glass in front of ceramic, and the ceramic holds a very precious collection of ceramics and other beautiful things. And then the wall of ceramic, glazed ceramic on the top. So this is the little detailed study that shows that. Wall of ceramic on the top, ceramic behind glass in the middle, and glass at the base. And this is sort of where it went. You just get a complete transparency at the bottom. Then you have the glass and the reflections on front of the ceramic, and then the ceramic. I didn't want it to be a grid, so you've got a common horizontal joint of rather large scale pieces, as big as shores could make, effectively, some of them. And then these fins that are formed and cover the vertical joint, and that breaks the tyranny of a grid, and gives a sort of a modulation that isn't absolute. So there are 3 sizes of tile, and you can see how clear these sort of corners are, perhaps. So that the way in which this is made is as 50 mil thick units of ceramic that interlock. So they interlock one on top of the other, and you form the corners. And then the fins are similar. But it's just very interesting here. It's a crafted glaze. This is the finishing of what is a cast material, not an extruded material. There are plenty of products that are a bit like the aluminium industry, that are thrown through, are pressed through a die. This is cast, so it has that sort of sense of being plastic, of being able to be sculpted. And then the finishing of it is very interesting because there is obviously a synergy, and a very nice one, between glass and glaze. So the idea with the glaze on this, just going back to this, was to create a layering. So we worked with Shaw's to produce an underglaze, which was darker, and then out of a sort of series of accidents, really discovered a top glaze, where if you turn the pressure down on the application spray, it's spattered, and by putting a kind of titanium into that top layer, you created a depth in the glaze, single fired, but you got a depth, and that works with the fact. What you can't see with this, of course, is that the trees move in this. So as you walk around the building, the whole thing has that sort of very ambiguous sort of sense of presence. It's not in the way that stone absorbs light and casts very clear shadows. This is moving. It's ambiguous. As the glaze, you can see the trees up in this, but you also see them in the glass, and then below in a different way. So it sits in its garden landscape and responds to the garden landscape. The next application, actually, was sort of running side by side, was to do with using ceramic in a city, but in a particular place. So this is a project for Scottish widows, where we took, it's New Bond Street, 30 metres this way, 90 metres through there, going right back to the Hanoverian origins of this grid of London, with St George's, Hanover Square just off the picture, Maddox Street, beautiful Regency row of buildings, and then this listed building on the corner, which is sort of Edwardian, in faience, so in ceramic, with granite columns, and very ornate. And at the bottom of it, it has the shoe shop Pinet, and if anybody's interested in leather, it's always a great window to look into. They will have skins of most exotic kind allowed, of course, and sustainably sourced, and other but remarkable artifacts, most beautifully made things, and that's what New Bond Street's about. Whether it happens to be pictures, or it happens to be silver, or Sotheby's, and then fashion. Obviously, Armani's just there. So the question was to design a new facade here that is also with this door into a new office building behind. So this is about urban renewal rather than replacement. 2 new office buildings. This is a new building, facade of a second office, which meet in the middle behind this. Very sustainable. When you go through, it's very noisy, obviously, here, kind of 80 decibels. You go through into the courtyard, and it's almost silent, so you've just got opening windows. It's lovely. So it's an urban block that's transformed. But the question was, what do you do in New Bond Street that reflects that sort of artifice, that sort of sense of celebrates making, the human imagination? And that was the attempt here, with a sinuous, snaking set of elements that you just see running between oriel windows. So you get that sculpted form because you get the broken E, and it makes all the difference. It's like the lack of movement joints in the brick building that I showed you. Absolutely critical to the success of this was a crafted finish of ceramic with a similar, you can see here quite well that overglaze that gives you the snake-like kind of quality to it. And here it is, fixed by stonemasons, so made in Darwin in Lancashire, dry laid, every piece laid out, so the whole facade laid there, comes down to site and fixed quite traditionally by stone fixers back to a skin. And that brings me to my last project in this, which is getting towards that question of the artificial in again. So this is the state of this bit of Piccadilly as it was. Eros is just down there. So it's a sort of Evening Standard shot of London in a way. And it's very interesting. As ever, the planning process is a difficult one. It should be open. It is an important dialogue. People love the environment they live and work in, of course. The planning officers were particularly fond of these 3 buildings because, and this one is a rather good one, I must say, because they represented a period before the architects of the early 20th century, so the 1920s, got their hands on Piccadilly, and they had a conspiracy. They were going to turn Piccadilly into a Rue de Rivoli. So the Ritz is one example, and it goes all the way down here. Norman Shaw, Reginald Blomfield, a whole series of. There has been very recently a very good exhibition on the buildings of Piccadilly. It's really interesting, and some great architecture, very inventive architecture. You think of the Wolsey building, the old automotive showrooms and so on that were part of this. Well, it starts here. We all know Lillywhites, and then Blomfield had a kind of, and his acolytes had a symmetrical corner at this point, but it sort of blew out of steam here. This was a slightly earlier building. This was too. This is a Waterhouse building, very good bank building. You can still see National Provincial scrolled into it, so, there it is. And it had a corner. And here, this building is an eclectic old building, actually. At the bottom, it was clad with these marble panels. Actually, it's Baron's. That's Ali G's father's shop. Baron Cohen. So, but it was really wrecked in the 70s. There's a beautiful piece of corbelling behind that. But the cornice this is a block, so it's unlike London that you get a rhythm of blocks here. The wonderful Simpsons building. It's a fantastic building, on it goes, and then St James, Piccadilly. So my point was, this is the Crown. The Crown have done a huge amount of work in Regent Street, as we all know, over the last 10 years. As their leases fall in, the same thing is now happening in St James. They have big ownership in St James. And this is their first renewal project, which was to take half the block. And as in the last project, I didn't go into it, but there is residential on the site in New Bond Street and Maddox Street. Here, the same thing. We increased the. I likened it to a kind of urban dental decay. It was hopeless. You had lots of little buildings with their own staircases, DDA accessible problems, and a hole in the middle. So. This was where I wanted to take it. You'll see this is an early sketch just showing taking the cornice. We took this building down stone by stone and put it back 6 foot higher so that it works running through. And actually, although it's expensive, in terms of the whole project, it's taking that pride. The stonemasons loved to show people around this. You had a ceramic facade, then a stone facade, a new stone facade, and in Jermyn Street, a retained facade. There was such pride. Come and look at this. Look what we're doing here. It's just wonderful sort of sense in which a material, you might throw it away, but it's got another 200 years of life in it now with a new backing. It's great. Anyway, I wanted to recreate the cornice and therefore behave rather traditionally, if you like, with this new ceramic facade. I had very vertical, these 6 bays in the facade that are double-storied with oriels at the bottom. A sort of bottom, new retail to clean this up. Clean up this unit. It's immediately been snapped up by a very interesting fashion shop. And then I always saw this as an art project. And using ceramic here, I wanted to use ceramic here with an artist to celebrate colour and not a crafted finish, to celebrate polychromy. So this were some of the urban studies with this new facade being placed in here. And this is the detail. Now, the interesting thing, again, this is Shaw's project, won in competition. The great thing about ceramic is it's sculpted. It's in this sense it's molded. It's put into a mold. Once you've got the mold, you can do it. You can repeat it. So you get a lot of complexity in any one of these vertical elements, but it gets repeated. So a lot of detail around the bases. There are very nice details on the returns to these piers. And then there's the special piece at the top. And it's the first time Richard Deacon has grafted his work. So his work kind of grows out of the architecture, the body of the architecture. So this is his cornice, which isn't quite yet unveiled. It's made of 39 pieces. You're looking at it, as it were, as a spectator underneath it. It's a cornice. It does that job of kind of working. Some of these pieces are about 200 kilos. They're like, because Shaw's make Belfast sinks, so these like supersized Belfast sinks. But we then work very hard with another ailing little firm in Staffordshire called Tadema, who do transfers. So, if you made models as a child, you had the decals and you put them on with water. Well, this is the same process of taking the 30 colorways that Richard had produced by hand and giving them an authentic, going through a long, long process of getting the color right between the kiln in Stafford, the kiln in Darwin, in Lancashire. So each of these facets has a transfer, which is up to 7 or 8 silk screens of the ceramic material. These are twice fired, so they're fired once and then fired in. So it's a ceramic glaze, and it's got this fantastic colour. This is actually, so this is the laying. Again, it's very traditional. We had to design the background to the facade to be very stiff, so we could mortar and put this on, not as a rain screen, but as a real finish. To me, that's incredibly, with lime mortar. So we worked out a system to get this. I always saw a blush, if you saw those sketches, a blush in the recesses, almost like a made-up face. So it's very white, black, and red. You know, you get these fabulous sort of sills and returns. So this is it in place. But it's all covered in paper at the moment, so you can't see Richard's work. That's going to be unveiled next week. But it picks up the ceramic. Of course, I always saw it as north-facing in the shadow, and it would pick up light. And actually, at night, the wash from Piccadilly Circus, from the digital display, sort of washes across the facade, which was my intention. It animates it, and it's a sort of smiling building, I hope. And I hope this really is a celebration of the art of architecture and visual art. So there it is. This is the CGI, which the day that the CGI is better than the real thing, I shall quit. But anyway, it's stretched here. So this is new retail units. The bottom, this retail corner, what was a bit of a dead space, new office entrance into new office building, residential behind, residential on the corner, new life to an urban block in this incredibly important location. Thank you very much.
Hello, thank you, Arup, and thank you, BDA, to invite me. Saying that, I need to say I spend almost every day of my life by myself in the studio, and suddenly I need to talk about in front of all of you, so I try to do my best. My journey with clay is quite simple. My main was to try to rescue material where my native of my continent were mastered. The pre-Columbian art and the landscape of my country were the pillar where I founded myself to start the journey. I always was surprised about the way they building the pieces, how they related with the landscape in terms of color, texture, and the earthy. And I must say, we need to remember the pre-Columbian art must be the most original art because they have not knowledge about the existence of new civilization, another civilization. Mediterranean was always in contact with different civilization, and if you go to the different museum, V&A, you can see the mix of celadons, metal, Arabian glazes, and so on. No? So when I arrived to Chile, I studied in Barcelona because was not a very good way to study ceramic because I think it was, for history speaking, the native people of my continent were hidden. So my first exhibition I did in pre-Columbian museum in Chile to try to put together this broken chain. No? During the 87, when I did this exhibition, 88 I think, was very hard for me to find material, raw material. So I need to knock the door for different ceramic industry, tile, bricks, if they can sell me some minerals, and even was complicated to find clay. So I did everything, and I hope not only the form, but also you can see how I've been working with the material and try to be concentrated and reconcentrated in a material I really believe, and I make it talk in different way and using the way of its expression, how it reacts in my favor. I want to talk about pre-Columbian art, but not in the romantic way, just touch, to put my countrymen in contact in a contemporary way of ceramic, using the landscape like my inspiration. In 1991, I received a scholarship and I tried to find new material to mix with clay. Shortly, when I was traveling around Chile, I realized it's a lot of industrial waste is coming for the process of mining, process of, it's an industry of a scallop and this pile of shell. And I try to use those materials. And I'm not a chemist, and I don't want to be, I was clear, I don't want to be an expert in the periodic table, because I really believe in the deep knowledge of the ceramic and the reaction of the clay, and a sense of adventure can bring me in more exciting and in more innovative ways to find texture, colors, or new materials with the clay. When I think the best sample of that, or most easy for you to understand, is my work I did with Jerwood and Baggeridge brick. I was lucky to do this work in Baggeridge. I was working with the engineering brick, the black brick there, and my challenge was, one, to make it work in organic. For sure, for many years, this recipe was made to make it engineering, resist, but not tactile, not organic. And the second one, to change the color with my own recipes. I have no time to bend, to testing match the clay, because the size of the kiln, the long time of the process will take long, and also the risk of bend the pieces will be enormous. So my challenge was make it organic, make these pieces, when it was wet, was nearly 4 meters high, 1 ton each. Then after the kiln coming 3 meters 20, you can imagine how complicated, you remember, Alan, to move from where I built these pieces to the kiln was success. Baggeridge was fantastic during this time. But my also main thing there was in terms of color. If the pieces have a little damage or a damage, well, the color remain intact. I was very, and still very great, happy with the result. Not one little crack in the pieces. It's 1 ton, quite thick wall, and it's not 1 centimeter crack in each of them. And then, for sure, my experience with Baggeridge, moving in the direction I was looking for, when I think these organic pieces was kind of the coronation of my work, and I was thinking to move in another way, to express with, like I say, with the material in different ways, not only in the recipe, but also in the way to construct with the clay. That was a piece I show in the Economics Plaza, talking about, raw material, how ductile, and how we can express with it. Then I was invited by Sotheby's to do a work in Beyond Limit in Chatsworth. And then I arrived at the point where I want to be. I'm working with porcelain for the first time in my life. I'm working with brick. I always, in my exhibition, I've been trying to work in the ceramic subject, in terms of pot, the inside, the outside, pre-Columbian art. Now I've been working with the subject of the brick. This piece was called Fusion, and was the experience for me to fusion myself with this new culture, like it was fusion, Marco Polo fusion Europe when he discovered porcelain and bring here. I try to do something different. I mix with my own clay, the blue clay. I'm mixing with different industrial ways. It's coming for the, Chile is rich in copper. I'm using a lot of waste for the mining process, and mixing with the porcelain. Try to do something more original, more craft in the way of handmade. I think is one of the things I like in brick, is this warm thing. But I think I really feel we need to be more adventure. And I did blue and white because it's a kind of reconnaissance of blue and white in the Chinas. Since there, I stopped for 2 years. I talked with Madeleine, it's the gallery who represent me in Newer Center. And after 2 years, I showed this show. Is called Brick and Mortar. I put here more close-up images of what have been done, because I think would be more interesting for you, just the piece, more than the piece itself. But I'm using in my favor not only the recipes, but also try to be adventurous in the way to build with just clay, different way, and like I say, to use the reaction in my favor, and also to use the possibility we have today with mortar, with this new resin where you can make pieces fixed pieces, and with 3 or 4 dots, you can hide 1 ton of clay. That is a work I just finished. That is a close-up. It's a 12 ton of clay, almost porcelain. Each block is 150 kilos, and it's 6 meter by 5 meter, by 1 meter 70 high. Working and try to make the porcelain work or the clay in different way and in different shape. Some pieces thinking for inside can resist, some other mix thinking for outside and can for sure resist a lot of time. Like I say, I've been trying to draw, if I can say, badly. When I'm arrived at the organic, a kind of perfection in everything, I think was very dangerous for me to overdone. So since then, I've been trying to be more playful, more adventure. I think try to broke the orthodoxian things about ceramic. We have been too orthodoxian. The people who work in iron, they weld and it's fine. Why we cannot use in our favor the new technology? With the clay, I try to be, with the material for these pieces, using very simple form, but very playful bricks. So where it can be more Baroccan or can be used in my favor what I want to express. I have thousands, literally 10,000, 15,000 of different tests of glazes, body of work. In the artwork in ceramic, the body of work, the clay, need to have a balance in between the form and the material. No one can win to the other. I always try to make the balance in that and speak together. Yeah, you can see how it's worked. That piece is almost 400 kilos, and I have been driving. This piece is, I think, is the link in between my organic form and the brick. I make square and I make block the organic form, showing the people and talking the history of building in terms of, I think, our first home was the cavern, and that is the way we build today. So was the link in that exhibition, brick and mortar, of my old work for the new adventure. All this body is solid, and here is the piece I showed before. That is 700 kilos. I take from there, and it resists. It's not Roman art, and you can see it. So I'm really using and expand my possibility to use this new mortar and in more, make me allowed to make big scale. That piece is, each block is almost a meter by 70 high, 150 kilos solid porcelain, supposed to be not possible to do in solid porcelain, but I've done, and it take deep thought in terms of how it reacts and how I can use in my favor. This piece is around 600 kilos. I try to be playful for a very antique material, like we say. The brick have been with us 11,000 years, but I think need to be more playful, more adventure, and that is what I've been trying to do. That is a piece of more or less 1 meter 70 by 1 meter. And I'm happy to say I'm still researching the clay and the way to use, and I think it's one of the most beautiful material the earth can give to us. And I hope in this short talk I can show you 30 years of experience, and for sure we can continue to find new ways to use that in our favor, the material in our favor. Thank you.
Good morning, ladies and gentlemen. Thanks to BDA and to Sarah for inviting me along here today to talk about Tate Modern, which is a project which, when Sarah asked me back in November to come and talk about it, I was maybe a bit sceptical to start with, because this is a project which hasn't been built yet, and we're probably now coming towards the important bit, and this project has been in the designers and engineers' minds and clients' minds for many years now, but the time has come to deliver it now. So what it is effectively is, you'll all probably be aware of in London the Tate Modern, which is just on the south side of the river, over the bridge from St. Paul's. Tate Modern was an existing power station which was transformed into a modern art gallery, and this is Tate Modern 2, which is a massive structure at the back of at the south side of the existing Tate Modern, and it's going to be clad in brickwork. This building is going to be a new world landmark for London. Obviously, we've seen some considerable landmarks in London go up over the last few years, but all of are different in their own ways, different methods of cladding, and we're delighted that at last we can get one that's going to enhance what we do as a trade, and from a historic point of view, it's going to be fabulous when it's built. It's a unique building, and we believe it's as thought-provoking as the art that will be displayed within it. From a structures point of view, this facade effectively is a non-load-bearing building. It pushes the boundaries of what we believe are possible with brick, and that from an architectural and obviously from an engineering aspect. The water tightness of this building is been afforded by the facade that sits behind this. So this is effectively a coat that goes onto the building. The structure itself is what's in these bold lines. This is the existing switch house, which is probably the most straightforward part of the project. And then we've got this building here, which is effectively a square, twisted, and having its top cut off. The important parts for us, and the difficult parts, are these crease lines and these corners. So every elevation has got a vertical facade along with an inclined facade, and it's the engineering that has gone into it to make it work as it is just something special. Where this project is at the moment is the structure is coming up. That's being built in precast concrete, and where we are with it in terms of our elements of work is we start in September probably. At the moment we're bringing the bricks in for it, and we're working with a team here which are probably a well-recognised team. Obviously, Herzog being the architects and designers, well known for their projects all over the world. Ramble from their engineering input. GTMS are the Tates project managers. Davis Langdon being the cost consultants. Mace being the management contractors, and obviously ourselves being the specialist brickwork contractor. So the numbers, just to give you a context of what we're trying to achieve here. We've got about 335,000 bricks, of which 212 are special types. When I mean special types, they're all sorts of cuts and angles to cope with and deal with the cuts and the creases that I've shown you earlier on. The brickwork is supported onto the structure behind with these stainless steel corbels. So these get fixed onto the building, and then our brickwork gets sprung off of those and fixed with dowels and components that I'll go on to in a moment. But we've got about 11,500 of these corbels that support the brickwork around the building. And these components that I just mentioned, we've got about 3.5 million of those, and they are effectively rubber and plastic bushels, stainless steel pins, and washers of all sorts of sizes and shapes and functions, obviously. The bricks are effectively 215 by 215 square, bonded together with a mortar and built in a perforated pattern throughout. The only place that this is where we've got the three elements. Obviously, just mentioning the perforated pattern, we couldn't have that on the lower levels because it would be a thief's dream to climb up that building. What we've got here is the lower levels are built in a solid, which we call the anti-climb zone, and these are just headers and stretchers which create the appearance of traditional Flemish bond, and they match the existing building. Section 2 above this then is the fade zone, and this is where the headers effectively are gradually recessed, and the higher it goes up, the more recessed they become. And they go up into obviously section 3, which is the full perforated pattern. The building, obviously, once it goes into the perforated zone, it'll look amazing, and it'll look equally amazing at night time, because a lot of this brickwork is built across the windows and the openings, and at night time, obviously, when the building is lit up, it'll pour light out through the brickwork, and obviously creating this lantern effect. So how is it built? Despite our efforts to try and source the bricks locally within the UK, because it's such a one-off, and the exacting tolerances that we needed to achieve, we had to go overseas to find the bricks. These are manufactured in Germany through an extruded process, but all the bricks are predominantly, most of the bricks are coming in with holes extruded into the brick as they're being manufactured. When we get them into the UK, at this moment in time, we've set up a facility in Colchester, and we're bonding these bricks together using a polymer modified mortar. Each pair is connected to the pair above, and these are done so by these elastomerics, and obviously the resins are delved in to secure the brick above this. Sorry about the faded nature of this drawing here, but this gives you an impression of the detail that's going into trying to achieve the tolerances. And we've got to achieve a tolerance of around 2 millimeters in every direction. So trying to do that with a naturally sourced material and putting them together with a pair of human hands can be difficult. This is a highly engineered project, and I would refer it as it's almost like a Swiss watch what we're trying to achieve here. So how are we building it? We were involved in the project probably about 18 months ago, and our involvement was requested on the basis of what is the best way to produce this product. We developed a system where we could take the actual bricklaying element of it off-site, and we created these jigs that enabled these bricks to be accurately placed together. Using the jigs, the results that we achieved were spectacular. They were set up, they're modified, and they're calibrated every day, so we can be sure that whatever bricks that we're producing out of them are absolutely spot on. So where are we? The traditional bricklaying practice that we would normally probably prefer to have used in these situations wasn't going to give us the tolerances that we thought that we needed to achieve. So how is it built? Obviously, the full assembly process, we've got 8 jigs set up in Colchester at this moment in time. We've got bricklayers working on these jigs, placing the mortar between the bricks, letting it go off for a 15-minute process, and then releasing the jig, checking it for position and tolerance again, and then storing these ready for obviously delivery onto site. This is again a close-up of the corbel. These, as I say, corbels, they're typically in at 1.2 meter centres vertically and about 900 millimeter centres horizontally. And they're obviously bolted back to the precast concrete frame behind. Pairs of bricks, and they're deliberately manufactured, so they're probably a 0.5 millimeter low. And the reason for this is that obviously once we put a lift of brickwork on the building, ultimately, we need to be sure that we've got some room to pick up tolerance. If our brickwork is too high when we get up to a point or up to the next corbel above, it's impossible to get it back down again without taking it all down. So what we've deliberately done is made the bricks a 0.5 millimetre, the actual pair of bricks a 0.5 millimetre less than they need to be. So we've then got a bit of tolerance to pick the bricks up to the correct level once they hit the corbel. This is an image of our guys in Colchester. The accuracy that we're achieving with this is obviously far higher and tighter than we would have ever achieved if it was a wet assembly on site. The site installation is not affected by inclement weather. Obviously, as we're aware, the last 8 weeks we've had difficulty with the weather, and it's effectively ceased a lot of our mortar laying operations that we've been working on. However, this is going on as we speak. All the bricks will be manufactured, ready for probably May, June time, and then we bring them onto site, and we work on the building for about probably 40 weeks to install them, which will take us right through next winter. And with that, whatever weather we encounter next year, it won't be affected by obviously the bricklaying activities. When we were again looking at doing some various tests and panels and whatever, this is what ultimately it will look like. But we found that using the jig process, the accuracy and the confidence that we had in getting it to where we needed to, tolerance-wise, was remarkable. And off the back of that, then we developed it even further. This brick pattern here that you see, in terms of the colour, this isn't ultimately what has been chosen by the client. The bricks are a creamier colour to what's shown there, obviously to match the existing power station. And the difficulty with it as well is, just to make it a bit more tricky, is that they're in 3 different colours mixed in a 1/3 pattern. So 18-24 months from now, that is ultimately what we're trying to achieve. It's a huge project, a huge challenge, and a challenge that we are delighted to have been given the opportunity to deliver. It'll be, as I said before, it'll be a wonderful landmark for London, and we've been immensely proud to be involved in.
Good morning, ladies and gentlemen. I'm Annette Forster. I'm the marketing director of Wienerberger, and we have about 30 minutes in which time we hope to share some innovative products and inspirational case studies with you. So in order to do that, I've brought along some co-presenters in the form of Darren White, Noel Cash and Ian McKnight, so divide and conquer. Darren's going to talk to you about Porotherm and how our clay block system is turning the industry on its head. Noel will talk to you about the Yard, which won the Best Public Outdoor Space at the BDA Awards in 2012. And Ian will talk to you about the Mac, which was the BDA Supreme Award winner last year. So just very quickly, Wienerberger was founded in the 19th century in Vienna. From 1819 to the present day, the company has grown into a leading global provider of wall, roof, and landscaping solutions. So we really are offering the complete ceramic envelope. We're not well known in the UK, because in the UK the business grew out of acquisition. So there's some local brands that's probably better known than Wienerberger. But it's important to note that we have 14 factories in the UK, 6 distribution depots, 13 quarries, and we employ more than 1,000 people. So even though we have a big global heritage, we also have a very strong and significant local presence. We are offering over 1,000 products for the new build and renovation markets, from bricks, blocks, tiles, paving to wall solutions. As I said, we're consolidating our brands. So what you'll see in the future is a lot more emphasis around the Wienerberger brand. And then in the wall category, you'll see brands such as Porotherm and Turca. In roof, you'll see our product brand called Sandtoft. And in landscaping, you'll see a brand called Penta. We truly are at the heart of product innovation. Our brick product range has increased by 150% in the last 5 years. We offer the largest range of plain tiles in the UK market. We have increased our clay paving range by 15% just in the last 6 months. And then we're also bringing new solutions such as Porotherm that Darren will talk to you about. We believe in innovation in all areas. So we look at product innovation, as I said, innovation in marketing, innovation in social media, for example, in our PR activities. We have a Wienerberger corporate social media channel. We've also been running a successful consumer-facing channel called Rooferpedia that will soon expand into all areas of the business. We've launched a successful brick app last year, and 2 more apps are coming this year, so look out for those. So in summary, look at us again as the complete ceramic envelope, roof, wall, and paving. Whatever you hear about us is probably going to be true. Next week, we're sponsoring an architect's talk at the boarding centre on Tuesday, so look out for that. We're doing a CPD at EcoBoard, so come and find us. And I'd now like to hand over to Darren, who will tell you why Porotherm is turning the industry on its head.
Thanks. Thanks, Annette, and welcome. Quite a bold statement, really, sort of turning the industry on its head. But it's a real pleasure to be able to stand here today and talk to you about Porotherm, because we certainly feel that it is making big strides within the UK market. And I'm going to give you a very brief introduction to Porotherm, because I'm very aware of the time. I joked with Sarah last night that unfortunately I can talk for England, and so I'm sure she'll start waving at me as I eat into the other presenters' times. It's okay. Porotherm. What is it? Everybody here today very interested in clay, so it's a clay block, and all we're looking to try and do is get people to replace a concrete block with a clay block for many different reasons, but they will unfold as I go through the presentation. Our main market in the UK is the cavity wall, quite simply because it makes up such a large percentage of the UK market, but we also offer a monolithic system, which again is gaining more and more interest. Okay, why is it different? Quite simply, it is a modern jointing method, but most importantly, it was interesting listening to Mike when he was talking about tolerances. We actually manufacture these blocks on the top and bottom surfaces. On my slide says there that they are ground to plus or minus 0.5 of a mil. They're actually down to about 0.3 of a mil now. So the tolerance level within the product is key. As you can see here, basically what happens is it goes through a firing process. We then grind it through tungsten grinders to give us that accuracy, and obviously checking that they are absolutely spot on. And that's what gives the system its speed. There's no mortar in the verticals, so it's a much faster construction. We're seeing sort of construction rates anything between 30 and 40 square metres per man per day on site when they're using Porotherm. And as I say, that's due to the fact that they're ground, so it's like stacking Lego blocks once we get the base course right. And it's also a much faster drying wall. So just to reiterate there, up to 4 times faster than traditional construction. No vertical mortaring, mechanical interlocking. And what we promote is we promote the independent leaf construction, so it gives you the potential for parallel trade working. So it takes the brickwork off the critical path. So for you architects, and it's really interesting seeing some of the projects today, if you're looking to do quite an intricate facade, being able to build the internal leaf of the building allows you to do that quite simply because it doesn't hold the project up. So we can get the building watertight, roof on, and then you guys can design as you wish, and that can come up as and when time allows. Quite a bold statement there, 95% less water, but just to give you some idea, with a traditional house, 200 square metres, you're probably using about 1,075 litres of water just alone in the construction. Okay, with Porotherm you use 72 litres, and I think that's a much harder hitting thing. So it allows internal trays to work much quicker. It's a strong block, 10 newtons, so one block fits all. Early strength gain, story height in a day, concrete planks on, timber floors on. We're doing it, and it's working. Basically, you can build to all codes for sustainable homes. They're all very achievable using Porotherm. Acoustically, it's very good. We're averaging around about 58 decibels at the moment, obviously against regulations of 45. And of course, it's an A1 fire rated product. Even though we fire it, as we do, the companies in the UK still asked us to set fire to it for about 4 hours before they would give us our A1 rating, but we got there. Also for me, it creates a much better humidity and breathability because clay obviously breathes. Again, the architect that spoke about his brickwork, he didn't want any movement joints. We would recommend in terms of movement joints 1 in 20 metres against 1 in 6. So there's advantages and costs there as well. It states there no moisture shrinkage. Again, picking up on some of the other presenters as well, Mike was talking about, you know, the weather conditions, and the past 8 weeks we haven't been able to do much work. We work very closely with a company and we introduced this last year. We called it Zero Plus. The reason for that, quite simply, is you can use it at 0 plus. So we are still laying blocks in the weather, and because you build blocks much quicker, okay, so even if we can only get 3 or 4 hours block work in when the temperatures are 0 and above, we're still able to lay blocks probably to the level you would with traditional systems. Fully accredited. We've had to overcome all of that. It's taken us about 4 years, but obviously it's okay having a great engineered system that works, but the UK drive for the accreditations in terms of NHBC, LHBC. Porotherm has all of those accreditations. We've had to work very closely with some of the key manufacturers. Capnick, Keystone, Berkeley are on board now in terms of lintels. Okay, they manufacture a special 2-part lintel, quite simply because, as I say, we take the external skin off the critical path. So we would build the internal skin of blockwork. We'll put a box lintel in from the beginning, and then when the brickwork comes up, we clip in the second part here when we bring the brickwork up. Same applies with wall ties. Because of the way that we do it, we can't have a hedgehog as a building. Health and safety won't allow us in the UK, so we've had to come up with a 2-part lintel. And again, quite simply, this blade is only 0.6 of a mil. That goes in when we do the block work, and when you bring the brickwork up, the leg simply clips in, and away you go. Lots of questions with regards to fixings. So we chose to go to, again, Spit Fixing, probably one of the largest fixings company in the world, American-based business. They offer a full technical service and backup with regards to fixings, because it's a question we get asked a lot of. It's a hollow block, how do we fix it? What happens if my telly falls off the wall? All of those kind of questions. So we offer a great backup service, and that's driven by Spit in the UK. It's also very sustainable. Obviously, key messages currently in the market: 30% recycled materials, has a life expectancy of 150 years. They are recyclable, our blocks. It's an inert product, it's clay, it can go in the ground, it doesn't have to be taken away, so it can be used for hardcore. Already talked about the water usage, A+ BREE Green Guide, and has a high thermal mass performance. So it's a good place to live. And also improves side values. So the thermal loss from within the building to the external skin, we've seen a huge improvement in using Porotherm. Some commercial considerations for people to think about: obviously reduced capital investment because of reduced build speeds, elimination of movement joints, reduced remedial work because of the shrinkage, no heaters required because there's a lot less water in the building, minimal wastage, and of course site prelim costs because we tend to be off site much quicker. Just a few case studies to go through to show that we're working with some major people. We tend to do quite a bit with care homes. The benefit to the care home provider is they're getting people in their care homes much quicker. Okay, this is a company called Baxter & King. They're on about their 5th care home with us now, so all very good. just talked about sustainable homes and what can be achieved. This was somebody that did a eco park in Scotland and used 5 or 6 different schemes to build the properties. We achieved a U value here, a performance, but a U value of 0.15, so code 6. They built these 2 bungalows in 5 days. So very, very fast. Never used the system before. And they used this here as monolithic. So there's no cavity. They just used a 190mm block as a monolithic wall and rendered and plastered. And they managed to get that kind of performance. And it really wins out on multi-storey work and social housing providers because a return on their money. Multi-storey, we're able to put concrete planks just on 100mm of porotherm without the need to back up with block work. I'd love to talk some more, but as I say, we are running to a time scale, so I'll pass over to Noel now, and he's going to talk to you about the yard. Thank you very much.
Hi, I'm Noel Cash from Henley Hill Brown Robertson Architects, and I'll quickly talk through this project that for Roehampton University. So, brief introduction to the context quickly. This is situated Roehampton, southwest London, between Barnes, Richmond Park. Basically, Roehampton developed along Roehampton Lane 18th century houses. We have Thomas Archer's Roehampton House with Lutyens additions later. We have chambers up in Whitelands here, and so it's 18th century villas. Grew up in this area, and which leads to the context of the campus, which was set up around James Wyatt's Grove House. So the project basically sought to unify a piece of grew out of a master plan that we worked on for the university. So this is the Frobel Institute, Digby Stewart College, Southlands College, amalgamated as one, and we developed a master plan within that campus for them to unite the 3 colleges. So from 2008, 2009, various interventions, and the yard falling in between 2 different colleges as a new connection between the 2. So a series of interstitial spaces as well as some capital projects. So the master plan has been progressing off the back of the initial master plan, and the yard being one of the first cornerstones which we're working on. So the site itself within the campus was an old trades yard, right at the heart of the campus, but basically a no man's land between the boundary wall, the Grove House, its capability brown, historic garden, and then the line between the 2 colleges, which were clearly divided. So this was a trades yard in and out, but effectively a no man's land in between the colleges. So we, as part of the master plan, sought to connect these 2 colleges in a more efficient way and actually relink all these ad hoc buildings and generate kind of axes through, which was, we basically demolished the old sheds along this wall. There was an old store here, but they had a diner which basically had a prospect of a fence and various other parts, chapel. But effectively the old route was through here, kind of very contorted around through series of corridors effectively to get back through from one college to the next with it gated. So we looked at opening that up, clearing out the old trades yards and actually making a new connection right through the campus. Connecting into a housing part of the site, the courts, the chapel, the diner, and a shop, pub. So this being the main new thoroughfare. The idea, once we removed most of the main buildings, we were left with a lot of eccentricities on site, slabs, buttresses, and etc. So we were interested in kind of, and the existing topography, sloping. So we tried to work with basically everything that was there by not removing anything that was unnecessarily. So we tried to, well, our intention was to use brick to unify all the various other ages of brick throughout the campus, the various editions in the 90s of kind of steel and clad buildings, which basically have kind of already lost their, let's say, I'm not sure they had much gravitas initially, but the masonry and historic buildings on the campus were the more interesting and certainly most precious buildings. So we chose a brick to realign this space, create this volume of brickwork, I guess, and to create a more harmonious kind of transition from historic garden to a court or a yard, as we call it. The university like to call it a square. But basically, as part of the master plan, we set up a set of precincts and courts. So the volume itself, then, the brickwork, we looked at, expressing all the various eccentricities on the inside of the space. So we kind of see it as a bit of a steel sheet piling kind of reversed on the inside and expressed as part of that, so that we can then create niches for shade and for benches and kind of individual seating and etc. Among a bigger space. So with the lower dining area, a larger concourse kind of space essentially to come out from the chapel. So here, colours are not fantastic, but you'll see where all the new structural and linings. Basically, we use the brick for the ground structure and envelope where building remains or unearthed that are revealed from the demolition itself. So the brick itself, because of the surface area, we were looking for a brick that could form in the ground. We wanted to use a brick on edge as opposed to a flat, and to give a kind of different dimension. And so we came across paver, which was unusual. It was 210 by 50 by 70 deep. It is various colours. When fired, it comes purple, red, brown, and silver, which you see in the sunlight. So it constantly changes. And then for the various conditions, we used for the new building envelope that from the internal parts that now become external as load-bearing skins. We used a 1/3 lap stretcher, which corresponded to the return dimension of this dimension of the brick. For the freestanding structural walls, we used a Flemish bond, which was actually like a combination of Flemish and diaphragm wall, freestanding, and in the ground, various permutations depending on direction of movement and opening up sometimes for growth, etc. So played around with that. We carved an opening through existing building, which to make that route less tortuous, so sunlight actually penetrates almost 70% of the space at times, and so a connection through from the historic garden beyond right through to the Digby Shore College. Shortened, created these new openings into the garden, these flat arches, and I guess some of the interesting games, a play of scale between, by using a 12mm mortar joint, we had a game of kind of 4 courses of existing matched with 5 courses, so they kind of catch up, and there's an interesting kind of play scale between the two, and there was a lot of repair of that existing boundary wall, which I'll come on to. This space basically became a room, so within the bigger space there's kind of series of rooms, niches. It was basically the space left from the big store that was removed, and kind of creates a nice pavilion, I guess, without being a room itself internally, and the movement through there. In the ground, we proportioned that space based on let's see, between the drainage, Roehampton's crest, university's crest. We played a kind of a game with stack bonding in the ground and some herringbone, which ordered that space a bit more on the bench. And you'll see, I guess, we played around with the the pointing, so for where your back is going to be there with flush pointed recessed panels where there's gates. Again, the boundary wall between the two was a bit of a mess and had been built on from the tradeyard shed, but it was curtilage listed in the ground, so we had to do a lot of conservation and to repair all these kind of junctions we quite enjoyed. The existing fin walls at the workshops actually were built onto were asked to be kept because they were now propping up the wall behind. So we lined those, strengthened them, some reinforcement, and basically emphasized these buttresses. They create shaded spaces in the summertime where you can sit, pull a chair and table across, and we lime washed, we crushed some of the brick samples to get the pigment in the lime wash of the old wall, some of the remnants of the floor slabs which we just simply lined over as mini terraces, and in the freestanding brickwork we created some niches and benches. We used a lime mortar with a small amount of cement to avoid any expansion joints anywhere. Just recessing some of the brickwork for lighting, and so it was about 3.4 meters high, so we had to add some cement to the lime, but in the historic boundary wall it was lime, and you can see how the diaphragm slash Flemish bond wall generates itself. And so again in the ground we opened up some of the brickwork to grow, so there's some thyme, etc., and various plants have now self-seeded over the wall from the historic garden, which is quite nice, and there's, it's aged even within a year, greenery within the tightly stacked ground. So single use of material, pretty much, pretty traditional. I'm not sure if it's innovative, but to kind of bring the consistency, that was what we did. So I'll hand over quickly to Ian to talk about the next project.
Sarah, how long have I got?
5 minutes.
Oh, right, okay. 5 minutes. We'll see. So 10 minutes to talk about the Mac. I'll do my best. At best, it's going to be a series of random thoughts, and you can try and connect them up yourselves. This is the second year, I think, in a row that Belfast has provided the Supreme Award winner with the Lyric Theatre last year. So Belfast is a brick city, and we've thought a lot about brick as architects. This is our first project of any real scale. So we've got a lot to learn and a lot to develop as we develop as a practice. But the thing that we were really interested in about brick is the variation, I suppose, in a way, a little bit like wine or coffee. It's dependent on a lot of local factors, the clay, the manufacturing technique for the brick, and then what mortar you use, what type of jointing you use. We have a huge archive of photographs just like this, which is a bit nerdy, I guess, but it's a reference point, and it's learning how those choices can transform how a brick looks. This is the Mac brick, which we selected to try and reflect something of the brickiness of Belfast. So it's not a Belfast brick, it's a brick from England. We don't make bricks in Northern Ireland anymore. But in terms of expressing a kind of clayiness that looks like traditional Belfast brick, this was the brick that we found was closest. What are we interested in developing the Mac? This is the site, part of the old sort of merchant city of Belfast. This maps from the first half of the 19th, well, sort of around midway 19th century map. This is the site now. It's been commercialised. This is a multi-storey car park with it was on the short list for the Carbuncle Cup in 2 years ago. It's made out of render and fiberglass and cast stone, and it creates a kind of an Italianate square, and the MAC completes that. And we're really aware that this sort of phenomenon of Belfast as a place is being lost. And this project was really try and re-establish some of the characteristics of the old city, and also to kind of, as an attempt to halt the sort of homogenization of construction. Somebody earlier referred to the fact that everything becomes about a series of products that are international, that you can buy anywhere in the world, whether it's China or Belfast or London. We wanted to make a building that was very specific to the city. And part of that was to make this space, which has some of the characteristics that the old streets of the old merchant city would have had, very tight, top-lit spaces characterized by sort of vertical surfaces of brick. The space is a public space in a fairly true sense. It's got a fantastic cafe bar that was that has been recognised at sort of the top 20 cafes in Ireland or something. I can't remember what it is. But this space is actually open to the public at no cost, almost as an extension of the street and square and public realm pattern between 10 o'clock in the morning and 11 o'clock at night. And as such, it has some of the characteristics of an outside space. Another thought, this is a rather neglected building in Belfast. However, if a building that had been constructed in the last 30 years had been neglected as much as this building has, it would look a lot worse. And despite the neglect, this building is valued. The idea of knocking it down would be resisted by the people of the city. And I wonder why that is, because it's not been designed particularly carefully. It's kind of ad hoc. It's used for karate. It's also used for architecture because it's where our office is. So we have karate, we have architecture, we have a dog food business. It's a big mix of things, but the point that I'm making is that these are tough, robust buildings that retain their use for a long time. We now have 6 of these brick vaults to work in. It's a fantastic space, and it's of interest to us that while some buildings get retained because they become culturally valuable in some way, this building is retained because it becomes valuable because it's existed and it's been tough and it's lasted for a long time. I'm being told to hurry up. So we were trying to reinterpret some of these qualities of the sort of traditional buildings. Belfast warehouses and mills would have used stone string courses and lintels and sills. And we wanted to reinterpret that idea using precast concrete. And again, because of the way the construction industry is set up, it's actually quite hard to do that. You have to work quite hard with the contractor, build mock-ups, look at all of the detail. Very important to the practice. And so just a few photographs of the building. Well, it was difficult to get through that so quickly. And you'll see here the kind of reinterpretation of those traditional stone string courses, sills and lintels using the precast. It's a lot harder to achieve than it immediately appears. The stone designed in such a way to convey a sense of weight and mass. And then the internal and external surfaces of the building are considered as a series of elevations, creating a sort of outside space on the inside. The practice spent a lot of time thinking about what that means for people and how you turn that kind of hard space into something that is welcoming on the inside of a building. And that involves a lot of detail and consideration of acoustics and how the furniture and the fit out close to where people are sitting creates a sense of softness, doesn't become reverberant or a tough or a hard space. That's me, Sarah.
I'm afraid I'm a salesman at heart, and the salesman in me doesn't allow me to let the occasion pass without reminding our friends from Northern Ireland the first Supreme Brick Award winning building from Belfast was actually St Bridget's Church, which we supplied the bricks for. So it's a great brick city, as we've all been reminded. I'm not here to talk about that. I'm here to talk about, let me get the right slide. Here we go. Press the right button. No. Right, I'm here to talk about what we call the maxima, sometimes called a Roman, sometimes called a linear brick. They were really introduced to our modern world by Peter Zumthor, much praised and renowned award-winning architect who this year won the Royal Gold Medal for Architecture. Peter is pretty well known to anybody who's in architecture. And of course, the building that put him on the map was the Columba Museum in Germany, where he used a brick which was 530 mil long, and it was a groundbreaking brick building. The use of this brick, which has become quite widespread now and is becoming more widespread, has become known as the Zumthor effect, and I think it's fair. Approximately 10 years ago, BDA, then under the chairmanship of Oliver Stevenson, organised a brainstorming session at Sheffield University under the auspices of Professor Till, who is now the Dean of Architecture at the University of Westminster. The day was organised to investigate and discuss how brick could recover some of the market it had lost to rather more modern and certainly at the time more trendy materials. I well remember Professor Till starting out the day by saying that brickwork or brick makers have to offer something different for the professional specifier. Obviously, from the talks we've heard today, that's now happening. And this is another element of it. Basically, the theme of the talk was that the 215 by 65 format had become boring, wasn't exciting anymore, and we needed to come up with something different. I suppose the landmark building was the Columba Museum, to which I've referred, but quite early on, my own company, York Handmade, was very fortunate to be introduced to a project, the Chetham School of Music, or Cheetham School of Music, which has used approximately 300,000 Maxima 327 by 50 mil bricks and around about 400 different types of specials. At round about the same time, we supplied 100,000 290 by 47 bricks to the iconic Shard building, which is much in the news at the moment. I think I just have to spend a little time now just explaining that flexibility is the key word. We are handmakers, we're very proud of that fact, but handmaking doesn't have to be old-fashioned. It can offer a flexibility which some modern factories, in fact all modern factories, find it hard to match. The key features here, if we can get this to work, yes we can, are it's still hand-thrown. Clay is still put into the moulds, but the moulds are in blocks of 4 in this case, and in them also you can have indentations, which used to be called frogs. In this case, the indentations were designed to suit prefabrication, which I shall come to in a moment. So we have a potential capacity with what I would call a mechanized handmade system to produce round about 15,000 linear Maxima bricks per 8-hour day. So it's quite a viable method of making bricks at a fair cost. We can do a great range of bricks. On the system you've just seen, with a rougher texture, you can do anything up to 350 mil. And you can also do a smooth textured brick, not on that system, but it's available from our factory. On the tighter textured bricks, more the traditional handmade look, I suppose, you can do anything up to 530 mil by 40 mil. So it's a very different animal to what we've been used to over the years. What are the main characteristics of linear maximum bricks? Well, our Danish friends like to refer to the strata look, which I think is a good way of describing it. Basically, you have long, seemingly seamless runs of brickwork. That's the visual effect, because the joints are usually quite heavily, the horizontal joints are more or less heavily recessed, and the vertical joints are flush. So it gives the impression of a long brick facade without too many joints in it. Again, quite different to what we've been used to over the years. I'm just going to let the slides do the talking now and flick through these fairly quickly. This isn't actually one of our jobs, but it's a well-known job. It's the Opera House in Copenhagen. It's a 530 brick, and you can see that there's some aspects of that which are perhaps rather unusual, but it's a highly effective and much praised building. That is, in fact, a shot of the Shard. That's a 290 by 47 mil brick, but again, the same format. It doesn't have to be recessed and flush pointed in the way that I've just been talking about. The architect still has the license or the freedom to use any mortar or bonding he wishes, and that's another example of different treatment. Some architects, or users, perhaps I should say, at this early stage, a little bit cautious, stick to the more traditional jointing, and it suits them, and I think the brick still looks quite nice. So what are the main, we're now going to talk mainly about the main, the main attributes of the bricks through experience and through use. This slide is the Shard again. It's not well known for its brick, but actually there are 100,000 bricks used at the base of the Shard, and they're very, very effective. They've used the traditional joint, and they've also used specials. I'm now turning to Chatham Music School. Now, this is a particularly interesting building. It's large in brick terms anyway, and it's a landmark building in Manchester. But the significance of the building, and particularly in the context of today's discussion, is that it's part of it, a large part of it, is prefabricated. This element, which is basically 3 stories, which is where the music practice rooms are located, incorporates soldier courses, soffits, more soldier courses, specials around the windows, and it's they're complicated pieces of brickwork, but they work very well in the prefabrication art. And the other very significant factor, which mustn't be overlooked, is that the building is built on a long curve. So there are curves all over it. There's a little sharp nose, sharp nose at the beginning of the building, and then it's a gentle curve round it. So that is an highly interesting building, which I suspect will become a case study for many years to come, and it is going to be featured in the issue of the REBA Journal, which you're taking away with you. To get the prefabrication, you simply take the brick which you saw at the beginning of my talk, and you basically cut it in half. So though it's got the key for the concrete backing, and it's relatively easy to produce. The units are quite large. Approximately, I'm quite old, so I have to work in feet and inches, I'm afraid. But we're talking about roughly 12 foot high, and we'll go back to meters and about 6 meters long. So there we are. Gives you a rough idea of the height and the size, and they're substantial. And I think you'll agree they're very good quality. One of the early challenges, which was very much put upon us, made very clear to us by the contractor and the architect, were that, of course, the prefabricated section and the traditional section must not show any colour banding. And as we have what we call batch kilns. That was a challenge, but I'm very proud to say that I think the result shows a virtually seamless blend between the traditional and the prefab. A lot of radial bricks, as you can see here, also prefabricated and traditional. You can begin to see the curves now in these shots. This building wasn't finished when we took these, but it does give me a chance to just show you the traditional brickwork at the bottom, and there's a lot more up in the sky because there's a skyscraper bit where the actual classrooms for academic learning are situated, as opposed to the music section, which is down there. I just want to dwell for a second on the specials. As I said, 400 different types of specials did represent something of a challenge. For those who are not familiar with special bricks, and you'll be much more familiar after this morning's talk, but they are basically, individually crafted pieces of clay, and that's one of the bigger ones, which was used, I think, around the window. And each special simply has a brick mould, a wooden mould, into which you throw the clay. It's a simple art, and that's the beauty of it. Because it's not too sophisticated, it's not too expensive, and it's endlessly, well, the options are endless, really. You need a good joiner, which we do have, and he's an essential part of the team. Also, there were a lot of bricks used internally, also radial. This was traditional work, and the staircase goes from the about roughly from the ground floor to the top of the main building, and it's the main access route for the students to get up to their academic work on top. Well, I hope I've been able to illustrate to you that we do see this as one of the major ways forward for brickwork, as an exciting, innovative material using both a new format of brick and also, of course, prefabrication. So thank you very much for that.
Okay, good afternoon. My name's Frank Hanna. I'm the Group Commercial Director for Micommercial Brick Holdings, or MBH PLC for short. Firstly, thank you for coming today, and today's turnout is testament to all the hard work by the staff at the BDA. So, good. Innovation. I always remember an old lecturer said to me, innovate or die. So I've gone through life in my manufacturing world, sort of always having those comments ringing in my ears. Well, who are we? Well, we see ourselves very much as Britain's brick specialists. We're producing circa 70 million bricks, pavers and tiles in the premium sector of the market. We're the 4th largest producer in the UK, but the largest British-owned company. We have 7 iconic brands, 5 premium sector bricks, each uniquely different. We've got Hatton terracotta, which is hand-pressed architectural terracotta, producing from some extremely complex work in detailing. I often refer to it as our Formula One department. And we've got Tapperell Taylor, our arch and cutting production facility, which complements all of our brick manufacturing. We also have a supply tie-in with Aquarian Cladding Systems, a UK leading supplier of rain screen cladding systems. So before I move on to innovations, I've just put together a few quick slides to give you a feel for some of our recent projects, and also within the pack there's a summary slide of where we see the position of each of our brick plants in the market. This is the award-winning Holiday Inn Express we did in Manchester with our Blockleys product. This is the iconic St Pancras Station refurbishment we did. Over 250,000 Charnwood handmade bricks went into that. That gives you an idea of the kind of domestic housing work we do with companies such as Millgate Homes. That's over in Reading. And this is the award-winning Henrietta Barnett School, which I believe we're touching on later on today. The three MBH innovations I want to cover today are as follows: BIM, Building Information Modelling, I-line, and Synthesis. So are you ready for BIM? Lucian said, a working drawing is a letter to the builder telling precisely what to build. It's not a picture to charm the client. There's no doubt that building information modelling can be seen as the modern interpretation of that statement. We see it as a process of designing a building collaboratively using one comprehensive system of computer models. I'm delighted to announce the launch of our dedicated website to host our BIM data, which is bimbricks.co.uk. This making us the first brick manufacturer to have responded promptly to the requirements of BIM. We're also the only brick manufacturer in the UK to have an operational BIM specification database at this moment in time. So I'm proud to be leading the way in that element of the sector, and I suppose it only serves to underline our position as Britain's brick specialist. In June 2011, the UK government published its BIM strategy, announcing its intention to require collaborative 3D BIM on all its projects by 2016. I noted recently in a recent BRE study that over 67% of practices polled in the study said that they would be utilising BIM fully on all their projects by 2015-2016. Now, BIM enables a virtual information model to be passed down from the design team to the contractors and then on to the owner or operator. Each professional adds intelligent discipline-specific data to the single shared model, which reduces information loss and provides an extensive range of knowledge. This shared knowledge supports design making from concept through to design and construction, but essentially provides a value-creating partnership through the entire life cycle of the building, facilitating the exchange of information in a shared digital format. Our website provides you with BIM data for all the MBH brick products in formats which will suit the various software packages that are available. And to my mind, the objectives and benefits are clear. It's improving visualization. It's improving productivity due to easy retrieval of information. It increases coordination of construction and management documents. It links vital facility information and increases the speed of delivery and in turn reduces cost. So please, I'd urge you to come and visit the site at bimbricks.co.uk, and we've even got a useful, informative link to the government's BIM task group site, which is worth having a look through. Also, our data is currently being hosted on the bimstore.co.uk, which is the UK's leading database for BIM-related information. The second new innovation from MBH PLC I'd like to cover is eyeline. What is eyeline? Eyeline is our new contemporary product from our Charnwood plant. We've noticed a growing trend for longer, thinner pieces of clay that were coming in from the continent, so we set about providing a robust UK offering with total dimensional flexibility. I feel eyeline specifies demands for a British product to help fulfil the expanding market of modern, striking, contemporary design. It offers elongated elegance that can define new builds, harmonise with old brickwork, and in essence bring modern vision and individuality. Our eyeline product has a wide varied palette of core colours, 14 to be precise, and currently 6 blends. We've provided both a fine and coarse textured finish. We've made the effort to try and cover as many colours as we could, ranging from soft reds through to deep reds, greys and charcoals. And to help the design, we've chosen 4 key sizes. However, bespoke sizes are available on request. The key sizes are 228 by 47, 240 by 50, 290 by 50, and 327 by 50. They're all 100mm wide. Technically, eyeline is extremely durable and accurate. Dimensional tolerances are T2R1, and the product has an F2 durability rating with a 25 Newton compressive strength. Again, that's all downloadable on our website as a brochure. The final innovation I'd like to cover is our new synthesis range. So what is synthesis and what's it all about? At 3 of our manufacturing plants, we have a fantastic ability to create and manufacture pre-blended random mosaic brick colours. Again, like eyeline, it's quite contemporary and a reflection of current architectural demand. The products are available in a wire-cut format from Blockleys, a clamp-fired stock brick format from Freshfield Lane, and a handmade stock format from Charnwood. The combinations of colours are limitless. We've developed a core range of 9 blends, which we feel complement each other, from stark contrast to sort of sympathetic tones. And again, as you'd expect from us, the technical qualities of compression, durability, water absorption for all the blends are superb and extremely robust. Synthesis is also available in metric, imperial and bespoke sizes. Again, the essence of synthesis is to give diversity and ensure your building makes a statement. It's unique and it's enhancing our built environment. I've got some images of recently completed synthesis projects for you to take a look at, and hopefully this will give you a bit of a flavour. This is the Corpus Christi College we've just finished in Cambridge. This was done with the Charnwood handmade products. Quite a stunning building. We've just finished Falmer Academy, the Aldridge Community Academy in near Brighton. That was a synthesis product from the Freshfield Lane plant. And as well as these, we've got many other examples. We're just finishing the ITV building, and we're looking at a case study for Crayford Town Refurb project, to give you a few others. So that pretty much, I'm conscious of the time, that pretty much covers everything that I want to cover. So thank you for your time. I've been brief as not to bore you too much, and I'll take any questions if there are any.
Okay, so I'm going to talk to you today a little bit about thermal ceramics. Now, this was a research project that I developed while at UCL. and I've continued to work on it for the last 4 years or so. I also work for Foster and Partners. So I've got a background in architectural design. I'm a fully qualified architect. And basically, I kind of come at ceramics from another point of view. I'm just going to talk through this project that I developed. And it was sited in North London. And it used to be an old brick field, the site, before I kind of visited it. And now it's a community estate centre. So I wanted to look at the qualities of the site. And in exploring it, I noticed that actually I could use the clay on site. So the main sort of theme of the proposal was to look at constructing materials available from the site. So London, in actual fact, has 95 metres of clay beneath it at any one point on average. So that was kind of an interesting fact. The other interesting thing was on the site, underneath the site runs the River Fleet. And this I want to use to filter and clean the water. The building would actually function as cleaning, filtering the water, as well as using it as a as a way of heating and cooling the spaces. So that kind of tied into the research. I was also looking at the future climates of London, and it's expected to get much more extreme weather patterns with much higher temperatures in summer and cooler winters, as we've been experiencing. Further to that, I then wanted to look at hotter climates and see and to cite examples of the way that ceramics have been used. So this is an example of an African fridge called a pot in a pot, where you pour water over the ceramic, the sun heats down on it, evaporates the water and cools the inside. Similar principles used with the ziggurat ice house in Iran, where it used groundwater to cool the building. So I kind of took those on, and this was a very kind of quick initial start to the project where I started to develop sketches. You have a public level on the top of the building as a ground level, and then views down to the river below with a bathing level in the middle, and the water filtering at the lower level. So these are more kind of conceptual sketches looking at the interiors of the proposal, and I wanted it to be a very fluid aesthetic. So and this kind of tied in with the idea of water flowing through the surface of the building. So these are very quick plan sketches, just looking at the public level, the bathing level, and how it intersects with the fleet below. This more as more of a section, so I started to look at parabolic geometries to actually form the ceramic onto. So you can see again the river below and the bathing levels beneath. So that was kind of a very conceptual start, and it was intentionally so, and I was sort of looking at researching things while I was developing the project. So adjacent to the site, fortunately, there was building works going on, and they were just installing a water tank, and they were excavating out the clay from the site and taking it to landfill. So I thought, why not use that clay and start to test it and see if I can actually start to develop some of the ideas that I was experimenting with. So I started working with a ceramicist in North London, and these models are actually made out of the clay from the site. So I developed die plates to extrude through on a small scale just to test the ideas. So this and the kind of molds were formed by 3D modelling the geometry in the computer and extrapolating it to extrude onto. So you can see the kind of freedom that you can have. These are the fired tests that I was working on. So you can see all these pieces are completely hollow inside to transfer water through. And this was really a collection of prototypes really for parts of the building. So I was looking at the key details within the proposal and sort of seeing how I could make them and start to think about that. I then scaled up the process and started to build relatively crude die plates and looked at how I could actually curve the extrusions and create a different form, which opened up a whole new series of questions, really. So I was looking at the profile as well, so to emit water through, but also air channels as well, and they could also be filled with insulation, etc. So from that, I then kind of went and experimented some more crazier ideas and looked at extruding double helixes. So this was a test. It was a kind of a concept for a handrail detail, which is completely hollow all the way throughout, and it's just extruded onto a track and then formed, so it self-forms itself. So those kind of ideas then kind of transferred, and I started to look a little bit about firing and glazing. So I did a series of tests where I was experimenting with the porosity of the clay, and that then led on to looking at the building as a filter. So using the river water running through the surface of the building, not only as a heating and cooling system, but in terms of filtering the water and actually filtering the river through the thermal bars. So on from that, there was some further technical sort of details that I was looking at. So the water flows through with air channels. So the water transfers its heat into the ceramic and then in turn into the air. So that's flowed through the building and creates a sort of thermal diagram. So this is a plan of what the bathing space might look like in terms of not look like, but feel like. So as you walk through the building, you'd actually experience a different range of thermal temperature without going through from room to room. You'd actually feel the temperature gradient as you walk through the spaces. So I then further explored that idea, and this was a small-scale test where I used copper tubing, and this is a completely hollow model. And I used a fish tank water pump just to pump water through the surface of it, and then film that with a thermal imaging camera to see the effects of it. And it worked incredibly well as emitting heat through the surface as well as cold temperatures when you ran water through it. So that was kind of another level of exploration. And these were more of the sort of prototypical models showing the different features of the building, further developed with the specific details that I was sketching out at the beginning of the project. And this is more a little bit about the public. At the top on the right-hand side, you can see the sectional model through the proposal. And this was all made out of the clay from the site. So further to that, this is another sketch which shows a little bit about the parabolic geometry. But on the roof, I was also looking at a sort of curved surface where you could, had water flowing through it. It would work in winter to heat and in summer to cool. So you could actually experience it on another level. So you could lie down on it, you could sit on it, you can interact with it in many different ways. So further to that, I then visited Ibstock Brickworks in South Holmwood, and I noted that I'm sure we're all very, very familiar with the production process of bricks, but particularly I took an extrusion straight off the production line and then curved it. And this to me was quite an interesting kind of way of developing the project, because I kind of wanted to test whether standard brick production lines could actually be capable of curving extrusions as well, in line with some of the ideas and designs that I was thinking about. So I began then working with Western Meal and architectural ceramicists. Now they're specialists in architectural restoration, and also are doing up Windsor castles, and so they're incredibly good set of knowledge in terms of working with ceramics. But more importantly, they had a brick pug mill in their facility, which I then started to build a series of die plates for. So I was actually thinking about how I could construct the certain details of the project in more and more detail. So this is one-to-one. So this is an extrusion which is straight onto a turntable, so it self-forms itself into a curved point. And I also looked at wooden form works, so extruding and forming it around a wooden mould, for instance. These are the prototypes that I developed. They source all their clay locally. They're just based outside London. So you get the same amazing red character that runs through it. And I started to then look at jointing techniques. Now I'm going to sort of quickly talk a little bit about the surface profile, because it may look as an aesthetic thing, but actually it's also a functional thing as well. Adding curves into the surface increases the surface area and therefore better emissivity of temperature. So you can see there's also the air channels within it, so you can stack it vertically and horizontally. On top of that, I then looked at plumbing connections, looking at standard plumbing details and how that could connect to the extrusions. I also kind of took a more radical approach to it and sort of said, well, how could this be used as a complete system, the walls? So I looked at the idea of actually glazing, using metal-based glaze inside the ceramic to actually transfer electricity through the building. So that was a more kind of theoretical side to it, but that's very achievable. There's currently you can actually 3D print straight onto ceramics circuit boards, so that's something that's possible. I then kind of took the plunge and tried to see if I could construct the light well detail, which is the main feature of the proposal that I was sketching out earlier. And this is completely hollow and it's self-forming, so you extrude straight onto it and it spins onto the formwork, and it lowers and falls actually on a car jack, incidentally. But this was kind of a prototype, really exploring what could be done. So I was kind of working at as a sort of a more conceptual level. And this is what it would look like fired, so what you'd see through the bottom of the building looking up to the sky. I was also kind of, in working with all this, in extruding all this clay and working with it all, I then kind of thought a little bit about how you could manipulate the surface profile as it's been extruded. So currently all bricks are just extruded with one pattern and it comes straight through, and that's exactly what you get. But I kind of wanted to inset this process a little bit to allow a bit more flexibility in the design of it. So I came up with an idea where you could actually have plates that move in front of the extrusions and alter its surface profile as it's being extruded. So this kind of, I built this die plate and experimented, but this could easily be linked up with could easily be computer controlled. So you could get exactly the same thing every time, and then different patterns can come through. In particular, in relation to the project, what I was actually looking at in terms of this was a water feature within the proposal where I wanted the water to be directed down the surface of the wall in a very specific way. So that's hence the carving into the extrusion. This is kind of taking it to a different level entirely, and saying there's a large growth in research in 3D printing at the minute, but this was done prior to that actually being in existence. This was done about 4 years ago, these drawings. So I was theorizing that if you could develop a system where you extract the clay from site, you put it through a pug mill, and you extrude it on site in strata, which is then fired in pieces. So this doesn't have to be curved geometry. It can be straight. It can be whatever you like. It gives a huge level of variability of what you could actually make. And this is a kind of visualization of what a construction site could look like. And of course, that could potentially speed up the process of construction, but also make it a safer thing. Kind of on from that, this is a visualization of what the the bathing spaces could look like if the building was constructed in this method. So from that, I then kind of extracted some of the ideas from the project, and then took them further. So I came up with this concept for a cooling canopy, and also a cooling facade. So this is there's huge amounts of work, and there's a huge amount of experience in this room in terms of cladding. And as you'll know, all cladding systems are hollow inside. And I was looking to explore that as a use to run water through. So you collect rainwater from the roof and flow it through the facade to heat and cool the spaces inside the buildings, and to reduce the load of air conditioning, or which actually currently uses a lot of CO2 in the building. So in terms of that, you could create a cooling facade, or and you can actually then start to produce more curved geometry in the other experiments that I was doing, where I was actually bending the extrusions. I kind of showed that this conceptually can be done in terms of creating very fluid geometries for the front of buildings. I also looked at the notion of a cooling canopy, where you collect rainwater, which is then flowed through the extrusion, and then the sun hits it, evaporates the water out of it, and the cool air sinks below. And this opens and closes according to the different weathers and temperatures. So it's a natural system completely. So I'm just going to talk a little bit about 3D printing. And this is a process that's grown hugely in the last 4 years, with the first house expected to be 3D printed next year. And mainly they're looking at concretes at the minute, and that's where the trend is going. But I kind of want to offer an alternative, effectively, and say, well, why couldn't it be ceramics or clays dug up from the site, you reduce the embodied energy, take the amount of trucks that delivers all the bricks off the roads as a system. So kind of that's where the project went, and this is a kind of summary. This is a piece of public sculpture that I'm designing at the minute, which works as a heating and cooling system, which uses groundwater to deliver hot and cold temperatures. So it kind of aids. This kind of works as a social space, but uses the properties of ceramics effectively. I hope I've sort of given you some sort of insight, or just a series of ideas into the way that the ceramic industry could potentially go in the future, and possible sort of outcomes for that. Thank you very much for listening to me, and if you've got any questions, feel free to ask.
Hello, my name's Alex Chinnock. I'm a sculptor, which means I'm probably quite badly prepared and very nervous also, so bear with me. I produce, well, for the last 5 years I've been producing sculptures and pieces of furniture which are born out of a kind of conversations and collaborations with different industries or different manufacturers or different materials, and just investigating the possibilities and the processes that are out there, which aren't often applied to sculptural practice, but more often appear in engineering or industry or architecture, and trying to bring all of those possibilities into my studio or into my thought process to create projects which have a kind of a playfulness or a kind of a poetry. This is a piece I made last year. It's called, you've got to forgive me for my titles, I don't really know where they come from. It's called Telling the Truth Through False Teeth. And what we did was we took a derelict factory in Hackney. It was a 3-story factory, and it was a cannabis operation for 2 years. And it got raided, much to my disappointment. But no, that's not true. That's not true. It's being filmed. My mum will watch it. No, it was raided. It was a 3-story cannabis factory, and it was just tarpaulin, soil, fertilizer, and water tanks. And so what we did was we went inside and stripped it out, and we removed every single pane of glass. Well, every window was boarded up, and then every single pane of glass had been there for many, many years. So removing the glass took about 3 months, because I could only afford one guy to work with me. And it was like chiseling concrete. So anyway, we removed every pane of glass, and then what we did was we replaced every single pane with a seemingly identically smashed and cracked window. So in total, we replaced 312 panes. So we created 312 identically smashed windows using 1,248 pieces of glass. Oh, I've gone too far. Sorry, I'm used to looking at more images. So essentially what that is we would take a pane, and then what we did while removing the windows, we were taking scans of the smashed pieces. And then we put it into the computer, and we water jet cut every single pane. So it created 5 pieces of glass, and we removed the central piece, and that left 4 pieces, which created this identical smash and crack. And then we installed it, and we left it for a week, and somebody took photos, and it made its way onto the internet, and it made its way onto the 8th biggest website in America or something one evening, and it was viewed 500,000 times in one evening, and it sparked this huge debate around the internet whether it's real or not, and it just went absolutely everywhere after that. So things picked up a bit after that, actually. So that's a good example of taking a process, water jet cutting, and applying it to something that doesn't really have any use, but it's just exploring the possibilities of the process and the glass material in quite a kind of, I don't know, an artistic, playful concept, I suppose. Another project I produce is concrete Persian rugs. And so what I do is, again, this is water jet cutting. I take council paving slabs, and we design rugs. So again, it's about playing with materials and processes. And these pieces are very much a kind of a take on the materiality of concrete. And it's a regular trick, but it's a kind of a juxtaposition to create something decorative or soft out of a material that is rarely associated with such qualities. These continue. We've made one rug that had 600 pieces of concrete in. So the very complicated jigsaw puzzles, which was just built into a floor in Soho. And after months of designing, they cut the floor the wrong the hole in the floor the wrong size. So we're in a bit of trouble there, actually. This is another one. This has 250 pieces of concrete. And so these rugs, very much for me, are a bridge of lots of different things. They're a bridge of industry, they're a bridge of kind of artistic exploration, and they also tiptoe into the realms of furniture design. These also go outside, so they're more outdoor rugs, basically. This is for a company called the Sculpture House, which I founded 12 months ago. And what the Sculpture House does is, it's a furniture company, first and foremost, but it approaches emerging international sculptors to come up with ideas for furniture. And so we meet those ideas with a spectrum of fabrication companies for product development and a limited amount of finance, but we do manage to make it through. And so what they're essentially doing is bringing their practice, or the kind of concerns within their practice, material concerns or visual concerns, to the challenge of function and performance and durability. Many of the things which a furniture piece has to deliver. Nothing is limited edition, so nothing's limited in number, and we try and make everything as affordable as possible. So it's a real challenge to the artist, but what it is really is, it's kind of encouraging artists to apply their thought process or their creativity to new areas. And this is where, I mean, the kind of the feed to what I do and why I started the Sculpture House, the root of it is essentially innovation. And I think artists, they have quite a bad rep at times, but I think ultimately they do bring a slightly alternative thought process or a slightly alternative approach to things like furniture or engineering or architecture perhaps. And while they don't particularly have the training or the expertise to see the things through, I think collaboratively when artists such as myself combined with industry and engineers, etc., quite exciting or interesting things can come from that. And the Sculpture House, within our shareholder group, we have engineers, we have carpentry companies, we have metalwork companies, we have polyurethane companies, and so it's really creating a bridge between the art world and those that kind of can give fuel to the innovative qualities that an artist might bring. That's detail. What's nice about these rugs is, and something you don't really notice in council paving slabs, is how much tone and how much pattern is within the concrete. And so these really exaggerate those qualities. This is another one. This is 16 foot long by 8 foot wide. And this is Norboard OSB. I don't know why I started, and I wish I hadn't, but one day I started colouring in OSB with wax crayon. So the many, many wafers within a board. And so this was the last one I did, after 3 or 4. And this is 4 boards, and this took 7 months to colour. It's called Fighting Fire with Ice Cream. It was, titles are ridiculous, I know. But this was really interesting because what Norboard did was Norboard saw this and then they approached me, and it gave birth to some really exciting conversations. And it's an incredibly slow process given the size of their company. But we have started playing around with the idea of pre-dyeing wafers before they're pressed on the press in the resin to create the boards. And then within their infrastructure, they, of course, can cut down the boards into tongue and groove 6x2, 8x2 flooring panels. And you can control the colour combinations. So what you start to have is you could have multicoloured flooring, green and blue flooring, red and black, branded flooring, whatever. And it basically is another example of where an artist and industry come together to create a product which potentially, it probably won't, but it potentially has a life, because it's a nice combination of decoration, function, and kind of efficiency and affordability, which are a nice mixture of things to put together, really. That's another one. That's 8 foot by 8 foot, which it just took so long. But that one's called Straight Jacket Star Jumps. This is another piece I made with an engineering company in Norfolk. They normally machine aeroplane parts, but and they're now part of the shareholder group in the Sculpture House, the furniture company. But this was a moving breeze block wall. So what that was, it was a complete laser-cut steel frame, which kind of jointed together and welded together. And then it has linear actuators slotted into the back, and so you could create different movement patterns. So this would appear as a normal breeze block wall, and then slowly breeze blocks would start sliding in and out, and it was a very kind of, it was a muted tonal thing. It was kind of whites and greys and shadows. but it just animated something that's so mundane. And that's quite often what I do, is I take the familiar or the regular and I put a kind of animated twist on it, or I kind of exaggerate its qualities. And so with coloured OSB, I was lifting the material nature of the OSB, taking a smashed window, which is very common in Hackney, and repeating it 312 times, making a breeze block wall move, taking concrete paving slabs and giving them a whole new quality. So this is a breeze block wall, which I'd love to do, 100 foot long, but like that. So then I started to explore brick. I'd been working with glass, concrete, OSB, steels, and so I moved into brick, and this is a piece called Self-Employed, and it's a 7 foot, the diameter of the piece is 7 foot, and it's obvious what it is. It's a chimney that's seemingly kind of bent, and it pumps smoke around itself. So it was this kind of self-sufficient cycle, and I made this one with Ibstock. That's it, pumping its smoke. And it was called Self-Employed to create this kind of illusion of a self-sufficient cycle, basically. And then I went back to Ibstock, and I wanted to continue, because the Self-Employed, the chimney was a nice narrative, and it was good fun. But I was far more interested in the pushing the brick materially into new directions, and kind of defying the material nature of the brick, and taking it in ways that it's been done before, but I just wanted to understand the material a bit better. So what I made with Ibstock was a series of brick walls. I took the most obvious plain thing that's made of brick, just a small wall, and these were 8 foot tall walls. And I just did different things with them. So this was using just brick slips, which were glued to steel and then pointed, and then they were either water jet cut or they were applied to computer bent steel. And what was nice about that, it was just this bridge of the detail or the possibilities that computers bring with brick, which has a very rich heritage and history, and it was just trying to take an old material in contemporary directions. And so, yeah, there's just a few of the studies. I got particularly excited. I always saw these as models. They don't fit in my studio, they're so big, but I saw them as models, and I was really excited by the one on the right, and it was just this kind of effortlessness of how a brick wall has kind of got drunk or given up or slid, given into gravity. And so we set about designing this, which, as I say, those were just models or trials for bigger things. This is unrealized. It's to be realized in the coming months. You may have got an email from me, some of you, because I must have sent about 1,000 emails out. I know Sarah got one to so many people looking for a building, which we were allowed to rip the front off and create. So it would be a plywood or an OSB substructure, which would be clad with brick slip. So we would create a giant illusion where essentially the facade of a building has slid and given way, and you would see into the top of the building. And so the campaign to find a building was huge, and I've been offered so many buildings, but I was amazed by, but they're just ridiculous. I was offered a shopping centre and a car park and one factory that you could barely see the end of. It was so long, and so we're still searching. But there's two very good sites that I think are going to happen. But if anyone knows of a house or a factory that's about to be knocked down in the coming next year, and we could do this on, do grab me, because I could do with one. So it works on a commercial or a residential project, basically. This one's a bit twee, it's a bit of a doll's house, but I think combining this kind of playful idea with the physicality of the curve and the brickwork will toughen it up. So another project that we started is I was interested in the curve and the illusion and the fluidity of the brick, but I then wanted to take that apparent or illusory fluidity and make it genuinely fluid. So I set about designing a melting house where we would build a house with a roof and real doors and real windows. And I've been working on this with Simon Smith from an engineering company in Cambridgeshire called Smith & Woolwork. And it would, over time, the idea is that if we cast every brick in paraffin wax and then built the house with it with the right kind of buckling and twisting substructure or subframe, it would appear as though the building is melting and warping and twisting, and it would end up as just a rubble of tiles and doors and windows and just a pool of wax. So this is what, amazingly, we made this in January this year, and just out of shot is a huge pile of snow. But we set about melting the wax. This was about, I don't know, 180 paraffin cast wax bricks, which we used different sands in to cast them. So you just couldn't tell the difference. I mean, if you walked a metre past it or half a metre past it, you couldn't tell the difference. And so we set about melting it. And there it ended up as this huge puddle of wax and mortar. And that's the plan, to do a melting house in a very public space. And so, yeah, that takes me up to where I'm at now. So the year ahead is, the projects are, they bring, as I say, the materials or the processes or the concerns present in engineering or architecture, and they use them to very little use. But I believe in this idea that if you can explore possibilities outside of an immediate application, so you don't get blinded by the goal in front of you, and you allowed room to kind of create and explore and play, at the end of it, there is room for innovation and function and use. I haven't quite discovered my function and use and those qualities yet, but I do believe that myself and artists, through creative exploration, can give birth to innovation and exciting possibilities. And so that's where I am now. And we're just working on a upside-down thatched roof, which is the size of a house that would spin in the wind as well. But that wasn't made of brick or had any associations with brick. So I didn't go through the net. Anyway, thanks very much.
Good afternoon. I'm afraid I'm going to pour cold water on the way that things have been going this afternoon, because I am Beelzebub incarnate. I'm going to talk about testing. This is the one thing that none of the innovators really like to do, because I'm the one that always tells them the bad news: it won't work. I try to be a little bit more positive, because I try and tell them why it won't work and how we can make it better. So that's my plug for why to do testing. Where do we start? Well, I believe that this might be one of the first levels of innovation. We started off with the straw house, and the wolf got his tea. We started off with the house built of sticks, and the wolf got his tea. And then we built a house of bricks, and the piggy squealed all the way to the bank. Joking apart, is this innovation in action? One of the questions we should ask ourselves is, what really is innovation? And as you do, you dive into the realms of Wikipedia and find out what the definitions are. So, a couple of definitions here that I have cared to lift from the all-seeing, all-knowing Wikipedia. Use of a better, and as a result, novel idea or method. Okay, we can buy into that. So it comes from the Latin. So it refers to the notion of doing something different rather than doing the same thing better. Slight contradictions there, but hopefully both compatible with what I'm going to discuss this afternoon. Fitness of purpose, that's what it's all about. Here's a garden wall. Have you spotted anything yet? Well, it's a garden wall built of materials that were never intended to be used as garden walls. Can you say that they are fit for purpose? Well, they clearly are, because the wall works. So how do you define what is fitness for purpose? We have roofing slates, ridge tiles, burnt, overburnt, slumped, slaggy type bricks. But the innovative part of the builder here said, I've got a pile of this material. I'm not really sure what to do with it, but maybe I can build a wall with it. And for the last 10 years, this is actually the garden wall abutting onto the pavement of a property that my family and my wife's family rent every year, and we all get together in the one house. And for the first 3 years, I had never even noticed this, and I've been in the industry for the thick end of 20 years. And the more you look at it, the more intricate it becomes. So it's all about paying attention to detail, looking at what the potentials are, and sometimes thinking outside of the box. I hasten to add, this wall is a thick end of 40 years old. Unfortunately, there are people like me that write rules. And those rules, I like to see them obeyed. And in terms of the way that we have rules, we have this thing called Building and Buildings, England and Wales, the Building Regulations 2010. If you're going to build anything, you effectively have to abide by this. Or, if you're going to deviate from it, prove categorically that you're not putting people at risk. So how do we assess fitness for purpose? Well, we start off, and it's a matter of scale. So we start off with materials, and we build up materials. This is a high-resolution scanning electron microscope image of kaolin. This is the clay mineral that forms a lot of the clay deposits that we use for making ceramics out of. From materials, we then go on to the products. So out of those raw materials, we make something, we form them, and we make them. We then go on to systems, where we put everything together. And finally, we have buildings. These are the things that we're after. Everything that's come before is just an intermediate step in order to get us to the end functional unit of a building. So we start off with products and system developments in the supply chain. So you have the concept, you have the development, the trials, the prototypes, the production, the commercialization. Everybody has their two penneth. And then somebody like me comes along and says, you should come and talk to me a bit sooner than this, because we could have helped you earlier on. So there's a role to be played for testing and assessment. If you like, I am your subconscious. I am that niggling person at the back of your brain that says, why does it work? Prove that it works. Convince me it works. So at each of these stages, testing and assessment has a role to play. It also has an associated cost. Because, believe me, if you get to the end between production and commercialization and you haven't proved the concept in terms of technical ability, there's a big learning curve to be taken there. So products and systems. There are three ways, traditionally, you can get things through the assessment process. You either abide by harmonised European standards, you go for European technical approvals, or you go through the bespoke route, predominantly through a BDA certificate. If we look at the raw material side of things, in terms of the innovation, where do we start? A number of years ago, the brick industry subscribed to quite a substantial project looking at how we recover or how we use the large tonnages, over 1 million tonnes a year, of mixed cullet bottle glass and actually make it into a beneficial product for putting into ceramics to gain a benefit. So we crush the bottles down, we make them into a fine powder, a flour, and add them in. And in levels at up to 10, 12%, you can get some very good beneficial end results. You heard David Armitage talk this morning, and I notice David's gone, but this is actually some of the bricks that we made with his clay with 10% glass fines in. And we reduced the firing temperature, or the top firing temperature, and for top firing temperatures above 1,000 degrees, you're talking extortionate amounts of gas to increase the firing temperature just by 10 degrees. So we actually managed to bring the firing temperature down from these by about 40 degrees and improve the durability and the strength characteristics appropriately. We're not going extraterrestrial, but a number of years ago we developed a system where we produced Mars material surveys. And Mars itself refers to materials from alternative, recycled and secondary sources. These are the things that other people don't want that industry can use for its benefit. So this reduces take from virgin raw materials, holes in the ground. It utilises waste and byproducts from other industries. And rather than being inert, what we're looking for is active ingredients. So that could improve faster firing, i.e. speed through the kiln, or we could look at lower firing temperatures, so reducing the actual firing temperature, reducing the energy burden, the embodied carbon within the products, and thus reducing the overall cost. At the same time, develop this approach of actually how to sell this internally. At the end of the day, you have to get this predominantly through your MDs and FDs. So we came up with the esteem model. You can map out the benefits of any of these projects in a number of different ways, but essentially they fall into one of 5 categories or multiples of 5 categories. And that's, there's an economic objective, there's a strategic objective, a technical benefit, an environmental benefit, and finally a marketing benefit. Because as we've heard so far, we've had 11,000 years to get used to the fact that we build with bricks. You ask a marketeer to go out and sell that in a slightly different way, then you've got 11,000 years of past experience to catch up with, and they'll say, well, I know what you can do with bricks, thank you very much. But I think as we've seen today, there's an awful lot more in the portfolio that we can do. They just need another way of actually describing it. Again, we've heard about porotherm. And at Ceram, we worked with Wienerberger, or one of my colleagues worked with Wienerberger, in creating a design guide in order that the UK fraternity of block layers and construction professionals would actually get round to actually understanding how to lay these things. It comes as second nature in the continent, where they've been using blocks like this for a number of years. But in the UK, there was a great deal of, or should I say, one of the barriers to get over was getting people to buy into the fact that it was an easy system to build with. Just by way of inference here, if you look at the girder, or the I-beam that we're testing here under load, as you can see here, the block has carried the load, the girder has buckled. So that tells you an awful lot. But there are threats, because if you're not innovating, your competitors are. And where we're busy at the moment is in relation to the Green Deal. And one of the things that we've invested at Ceram, being a test house and consultancy, is we've invested heavily in the ability to test external thermal wall insulation systems. And I'm sure I'm not being shocking in admitting here that the majority of these systems are actually renders onto thermal insulation. But we've got 4 systems here that can take panels that are approximately 2.5 meters high by 3.5 meters wide, and test them at ranges of temperatures up to 70 degrees at 100% relative humidity and down to -20. We can freeze the proverbials off them, and we can sweat them like nobody's business. And this is the requirements. This is your proof of concept. If you get through these tests, you meet the requirements, as well as a number of other tests, I hasten to add. But predominantly, this is the fitness for purpose. This is how you identify whether or not your products and your systems are fit for the purpose they're intended. Innovations in facades. So what's new about this? I'll show you what's new about it. It's 4 millimeters thick, and it's not clay. It's resin. It's a render. They always say imitation is the greatest form of flattery. If you're not innovating, the risk is somebody else will. We know that there is a liking for brick facades, particularly within the domestic housing sector. The risk is if the industry actually doesn't provide innovative solutions, the competitors will in order to maintain those facades. And I think the irony of this is that how can you put a render that says brick effect? Why not have brick as being the brick effect render to the system? And then there's the falsies, as I refer to them, but the false chimneys or the prefabricated chimney systems. They give the architects and they give the planners the ability to insist upon having a non-functioning or functioning facility of putting on what is essentially a redundant roofscape, but in order to keep the continuity and the roofscape as traditional as possible. And one of the biggest test areas at the moment that we have in the labs for brick slip testing is actually on these systems and dormer windows. So innovation, it's all about understanding what you want when you start off on the journey. And there's just a couple of quotes to finish off with regards innovation. And you could say that we really should listen to these guys. Unfortunately, neither are around anymore. Steve Jobs said, "Innovation is not about saying yes to everything. It's about saying no to all but the most crucial features." This was his response to the industry when they said, "No, we want iTunes to do more and more and more." And he said, "No, we don't. We want it to deliver what it says on the tin, which is we want it to be the center of where you can download music from." And a little bit older, Henry Ford. "I see no advantage in these new clocks. They run no faster than ones 100 years ago." If that's not an insight, I don't know what is. Thank you very much.
Hello, everyone. I hope I was worth forgoing your tea break for. I'm Lex. Anyway, I'm from Arup. I work here in this building. I'm a materials specialist, specialise in brick and architectural ceramic materials, which we do on the second floor here when we're not standing outside observing fire drills. So I was going to start my presentation this afternoon by talking to you about the fantastic synergy that can emerge between ceramic artists, ceramic art, between architects, between engineers, and between makers and manufacturers. But I think the presentations that we've seen already this afternoon have already really, I think, made that perfectly clear. But I'm going to show you some examples of some of the work that we do here. Most of the work that I do relates to building facades on the whole. I specialise in timber as well, but it's mainly ceramics and brick. The kind of clients I have are everything from architects through to contractors, but also I work a lot with manufacturers and entrepreneurs as well, people developing new materials and other areas. I'm going to talk for around about 35 minutes with a sort of slot at the end for questions if you have any. And I'm going to be looking at what architectural ceramics are, trying to define them more clearly, how they've evolved and how the architecture of them has evolved, and also how they're made, of course, which we've touched on in many cases. And then for the last half of the presentation, I'm going to show you some of the fantastic projects that I've been lucky enough to be involved in, and some other interesting projects that I found really inspirational as well. So architectural ceramics could be bricks, of course, be they moulded, be they extruded. They could be extruded blocks, the traditional type used in walls and floors, or the highly perforated forms that we've seen from the likes of Wienerberger. They could be ceramic tiles. They've been around almost as long as bricks themselves. Or architectural terracotta, which evolved during the mid-19th century. Or faience, which is the close cousin of architectural terracotta, which is basically the glazed version of the material. Extruded terracotta rain screen, which emerged in the early 1990s. And some of the contemporary pressed ceramic materials that we've seen using basically, technically speaking, sort of porcelain materials. So brick, as we know, has been around. I was going to say it's been around for about 4,000 years, but Fernando's already gone up to 11,000, I think we're on at the moment. Any takers on 11,000? And it is, it is really one of the oldest man-made materials. It's really one of the first fabricated materials ever since someone presumably put some clay in the bottom of fire and realised if you can make it hot enough, it will fuse and make a solid material. Great for stacking buildings, and great for storing food and water. The history of brick itself is fascinating, but there's not time or scope to go into that today. But architectural ceramics, as I kind of know them, really started to emerge in the early 1800s with materials like code stone, which is basically a clay-based ceramic with bits of quartz and other stuff added to it. And it really evolved as a more durable alternative to natural stone. Our cities were really heavily polluted in those days. Some of the softer limestones and sandstones would erode very quickly. The material evolved into architectural terracotta. And the advantage of architectural terracotta, it was much lighter. You could form hollow blocks compared to natural stone. Natural stone was very difficult to move. You had to bring it a long way. It was very expensive. And you had to spend months and months up on the side of a building chipping away the highly decorative architectural details that were expected in the 19th century. There's now examples of architectural terracotta buildings in all of our metropolitan cities. This just happens to be my particular favourite. Generally, it's a very classically ordered building, but actually it contains some fantastic detail, particularly through the interiors, but also there's all kind of wild animals and creatures, some of them real, some of them kind of fantasy, emerging all over the facade. Things like the bottom right-hand image, there's a sort of chimpanzee head in a capital, and this rather worried-looking pterodactyl in the bottom left-hand corner. I know at least one of our guests today worked on some of the beasts on the cornice in the restoration. Architectural terracotta also became huge in America. I think somebody already mentioned the fact that it was a wonderful lightweight cladding to high-rise steel frame structures, protecting them from fire. It was fireproof. It would stop the steel-framed skyscrapers buckling. And I think the Flatiron is probably the most famous terracotta building that very few people realise is actually made from terracotta. And back in the UK, faience was also becoming extremely popular. So faience is the same material. It's a cast hollow block, but it's got a glazed, glassy-like surface on it. And it was a means of providing very clean, very crisp Portland stone-like buildings, but that were not susceptible to damage and pollution quite as much. But on the other hand, designers were also very quickly realising that you could use all of the techniques used in glaze from pottery glazes to create really vibrant, beautiful facades. This is another of my favourites, which is Michelin House. It doesn't look like it should be in Chelsea. It was a French design, and it fell sort of somewhere between Art Deco and Art Nouveau. Another great famous faience buildings, of course, the London Underground stations. We've already mentioned the fact that the glazes will, I think Eric Parry mentioned that glazes will be as vibrant as they were when they were made, and these buildings are getting on for 100 years old now, and the oxblood red glaze is just as vibrant. Faience and architectural terracotta continued to be extremely popular through the 1920s and the 1930s. Many Art Deco buildings, the Odeon cinemas, for example, the Bonham's Auctioneers on the left-hand side here, and this beautiful faience Art Deco building near Holborn on the right. But with the financial depressions and the war years, terracotta and faience very quickly sort of fell out of favour, and it wasn't really seen as a kind of material through the continuation of the modern movement thereafter. But Renzo Piano kind of came along and saved the day in the late 1980s with the Urcam extension in Paris, and this was part, of course, of the high-tech movement. And he took bricks stack bonded into and fixed into steel-framed structures, and it kind of brought some kind of warmth and humanity to a sort of high-tech, fairly kind of sharp-edged facade. And then terracotta rain screen was born. A huge number of proprietary extruded terracotta plank rain screen cladding products emerged on the market, mainly by German manufacturers. And they've become almost ubiquitous, almost as popular, probably as popular as terracotta and faience was in the late 19th century and the early 20th century. And they've evolved to form things like baguettes and various other types of shading device. And we've already seen curved extrusions. And they continue to evolve just as the buildings start beginning to look a bit stale and I say a bit ubiquitous. Someone goes and does something really good with glazes or with form. Sauerbruch and Hutton here. Oh, this building I particularly like in poor old long-suffering Spitalfields. This building uses German-produced extruded terracotta planks, and the architect has very elegantly selected the range of colours from the adjacent brick and stone building. So really picking up the colours of the lime mortar, the red brick, the natural stone, and of course also the coursing of the bricks themselves. And it's quite a gentle, attractive building surrounded by kind of shiny glass towers. This is really a sort of love it or hate it building. It's situated, for anyone that doesn't know it, just beyond the bottom of Tottenham Court Road, about 10 minutes walk from here. I flew into Heathrow recently, and as you fly into Heathrow, you can see two things over the West End that grab your eye immediately: the lights of Piccadilly Circus and Central St Giles here. It's made from really vibrant primary coloured glazed extruded terracotta planks and terracotta tubes that were fixed onto a unitised curtain wall system. So the cladding was all factory completed and then swung into place and hung off the building. One of the criticisms that sort of get given to this building, this of Renzo's buildings, and bear in mind he's the man that sort of invented extruded terracotta, is that it's too crisp, too plain. We heard Eric Parry talking earlier about how he loves the inconsistency of clay, and certainly the work we've seen of ceramic artists, it's the kind of inconsistency and the changes in the material that really give it that richness. A lot of people think this is powder-coated aluminium, which is possibly a fair criticism, but I like it. I think it's really, really kind of colourful. And it's not just extruded ceramics that the kind of innovation of today. There's a lot of work been done, particularly by manufacturers like Ceramica Comer in Spain, who did a lot of work with sort of pressed materials as well. They cut their teeth doing a lot of restoration of Gaudi's buildings in Barcelona, and here working with Enric Morales, you can see the sort of influence of Gaudi, but also the really vibrant colour of these tiles and this lizard-like sort of tiled roof, this chameleon roof. And of course, in Asia, there's a huge wealth of ceramic history, and this building here in Tokyo, using what must be a very expensive platinum-based glaze on a private house by Tadao Ando. I also particularly like this building. Porcelain is a fantastic material that we see sculptors use and we see tableware manufacturers use. It's not very often it gets used in its purest form for building facades, but this is a particularly stunning example. So clay, we know you can shape it, you can manipulate it, you can squeeze it out in all sorts of shapes and ways. This is production of typical hand-pressed terracotta. This is at Shores of Darwin again, who we saw earlier in Eric's performance. Other terracotta manufacturers are available, but I've also ended up working with Shores a fair bit. So let's go back one. A timber model of the piece, in this case, a restoration of a capital, is first produced. A plaster of Paris mould is then taken from that. And the clever thing about these moulds is that you can actually take them apart. You may or may not be able to see that there's different. This is made up of several different sections, so you can really kind of work the clay into different parts of the piece. And then the clay the mould is filled to about sort of 40 or 50 millimeters thick into the mould. and it's left hollow, and that's really for lightweight, to keep it light, but also to aid firing. And then the piece is allowed to dry and it's demoulded, finished by hand. If it's faience, it then usually gets sprayed with a glaze, but in this case it's architectural terracotta, it's unglazed, so it goes straight into the kiln. Where pieces are more repetitive, where they need to make, John, how many would you make? At what point is it more economical to make to slip cast pieces?
Probably about 30 out of the mould, but
okay.
Depends like on the complexity.
Okay.
50 to 30.
Yeah, okay. So if you're making sort of 50 to 30 pieces, slip casting is generally used. So it's the same sort of plaster of Paris mould. But in this case, liquid clay slip is poured into the mould. And you've got these little chimneys on the mould box. And the idea of the chimneys is that you can build up a sort of pressure head of the slip so that the clay is pushed right down into the mould itself. And the plaster of Paris gently sort of sucks all the moisture out of the clay and just leaves a sort of firm clay body. Here you can see some other pieces being demoulded here. So at this point they're kind of dry, they're kind of stiff and strong enough to handle and to put into the kiln. Extrusion we've seen, and we've seen Peter Webb with some fantastic variations on extrusions. I particularly love the double helix coil, which is a new one on me. I'd like to see that in mass production. It's great. But for now, manufacturers are just sort of squeezing out relatively straightforward shapes. Here's some rain screen cladding tiles. They're extruded back to back. They're then fired and the tiles are split afterwards. They are going through the dryer. Here's the finished product. And you can do all sorts of things with die shapes. You can extrude planks up to kind of 3 meters long. It's about the longest I've ever seen. And I mentioned earlier Cumea's pressing facility in Spain, coming up with all kinds of crazy shapes. So I'm now going to take you through some of the case studies and specific projects. And my kind of role here at what I try and do is really sort of bridge the gap between people like Andy and the kind of technical, the really sort of technical end of testing and trying to get products and systems through approvals, from the ideas that some of our clients have, often architects with some very, 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 very strong technical demands on a facade, such as no movement joints, which I'll come on to. The first one's a brick project. We've already heard about the Zumthor effect and how everybody's making long, thin bricks now. This is one of several examples. It's a building in Clerkenwell. They're Danish bricks. I tried to get them to use British bricks, but they weren't having it. And this building is kind of typical of avant-garde brick architecture, because the building it's a mixed-use development. It's commercial offices. It's retail at ground level. They've got very big shop fronts at ground level, which means that the load of these piers is transferred at ground level onto the columns. You've also got massive floor-to-ceiling windows. This means that you've got very slender piers, very slender spandrels, which means you've got a very slender primary structure. So we maybe get involved at stage, for those who are architects, stage C, probably usually stage D of a project. And at this point, the structural frame has been defined. And we often find that there's relatively large deflections. The centre of the slab edge, sort of across here, may deflect by up to 10, 15, sometimes 20 millimetres in use, so that the live load's on the building. And that was never a problem when you were building brick buildings stacked off the floor. The primary structure would just kind of do its own thing, and the brick facade would kind of do its own thing. But here we're literally cladding with brick, with 108 millimetre thick brick, but we're cladding the outside of this structure. And this structure's got to move without cracking the brickwork, or it will move. You can't stop it moving. And you've got to try and do that without cracking the brickwork. And that means loads of movement joints, but the architect says, can't have movement joints, it doesn't work. and you've got this long, again, this continuous kind of banding that David Armitage from York showed us earlier, these kind of horizontality of brickwork. So inevitably, I have to uncomfortably sit down at a meeting and show the architects their beloved elevations covered in red lines where we need to have movement joints. But sometimes we can be very, very clever about them. This building needed a lot, but by using these long, thin bricks, we also had raked out horizontal joints, which meant that the horizontal movement joints were almost invisible. So we used a coloured match silicon silicon sealant. It's the vertical ones that really stick out like a sore thumb. But we managed to sort of disguise those as well by using 3 different shades of brickwork in this case, and spanning like one individual shade across the movement joint, and then pointing the perp ends up with silicone, so that you'd kind of lose that. You'd still read the horizontality, the brick ribbons wrapping around the building. So they were quite pleased. I showed them the sketch on the left first, and they were kind of horrified. Showed them the sketch on the right, and they could sort of can't really see where the movement joints are. So there's clever means of hiding them. Complete opposite end of the scale from bricks. This is working with Renzo Piano again. This is a project we're working on currently for an art gallery in northern Spain. And these are light scoops, sort of shading devices on the roof. And these are again pressed in a Spanish ceramics producer. And we've been designing this sort of aluminium frame. That's a 3D model of it here, which supports the whole thing. There's the man himself inspecting some of the pieces, and a mock-up on the image on the top right shows the light scoops in work. This is a project I haven't been involved in, but I was trying to find what I consider to be the most innovative ceramic facade, and it's a project again in Spain. And love it or hate it, you can't help but admire the innovation of the form and the building itself. And it's clad with these kind of big ceramic tongues, and they're hooked over a steel cable net structure to the facade of the building. And these were incredibly complicated pieces to produce. They were produced by extruding a continuous ribbon of clay, which is around about 35 millimeters thick. Once that ribbon had been extruded, the manufacturers cut out the shape of the tongues almost like on a big steel template. You can see the templates on the trolley on the left-hand side there, rather like kind of cookie cutting dough. They were still quite malleable at that point, so the pieces were slumped across CNC machined polystyrene blocks and left to dry. At which point, artists came in and basically sort of slapped glaze all over the place and had what looked like a fantastic time painting these pieces with glaze. Call it work. And here is the finished effect, which is absolutely stunning in the sort of matte black clay body and the black glaze. So back to London, I joined Arup from the brick industry around about 5 years ago, and one of the first projects I worked on was Quadrant 3, which again was supplied by Shaw's. It's a project just off Piccadilly Circus. You can see Piccadilly Circus there on the bottom right, Regent Street curving away to the north there. And the plot was a 1911 Edwardian white faience hotel, which for various reasons of floor level and many other factors was going to be demolished. Dixon Jones, a very enlightened architect, decided to retain the kind of corner pieces, the cornerstones of the building, these big faience elements, and insert three new facades in the centre of the building. So here you can see the Edwardian end of the hotel, and one of the faience facades that's been cut back, one of the existing faience facades. And the solution we came up with, I was working very closely with our facade engineering at the time, was to use these faience tiles and then precast them as we've seen before with York's product. So each one of these elements is a single component, and then each one of the story height piers is a single component. So the tiles were slip cast at Shaw's. They were around about 40 millimetres thick. They were then sent off to Belgium to precasters, cast into concrete, and then shipped back, and then sort of swung into place on the building. So the whole building went up very, very quickly. One facade's green, one is white, and then the one around the back is blue. I particularly like the aesthetic of this building. It's a modernist building. It's a contemporary modernist building, but it really reflects the local materials, the faience, in the case of this blue faience, and of course the bronze shop fronts that are always seen around Regent Street. And this project we saw earlier, which Eric Parry talked at length about, which is St James's Gateway or One Eagle Place. And as Eric mentioned, it's just off Piccadilly Circus. That's just out of shot to the left of this CGI. I've been working as a facade designer and also as a materials specialist on it for around about 2 years. So I'm going to really just talk a little bit about the technical side of it and how we took kind of Eric's vision and converted that into a sort of buildable solution, really, which is something Arup have always been kind of famous for. We had specialism with stone, structural engineering, and then I was brought in to help with the kind of faience pieces. I produced this sketch at stage D, which I think really gives a good idea of the complexity that we were facing with this facade, because Eric wanted a seamless, sort of the appearance of a masonry building, this kind of seamless monolithic facade with lime mortar joints. And as I mentioned before, with the massive windows, very slender columns, and a primary structure that moves a lot, that's very difficult to achieve. Around about the time we were designing the building as well, Part L 2010 came into force, which, for anyone who doesn't know, the building regulations means that we've got to put a lot of insulation on the outside of the building. So we had to come up with a means of doing that as well, and then somehow get this facade on the outside. But we kind of achieved it within the zones. And the biggest challenge is trying to get that facade to respond to the primary structure movements without cracking. So what we're looking at here from a document we produced, this is facade, of course. This is a simplified sketch of the facade. And we took all the data from the structural engineer. Arup weren't the structural engineer on this project. And the structural engineer reckoned that the primary structure under the most onerous wind load that the building's ever likely to see was going to move about 40 millimetres left and right and in and out, which is a staggering amount for a brittle 40 millimetre thick ceramic cladding to withstand. Not only that, each connection, these big sort of concrete encased steel components, were heavily fixed together in what engineers term a moment connection. So rather than just sort of simply sway like this and the two kind of components do this and pivot, what would actually happen is the columns would bend into a sort of S form. The worst case scenario was on these sort of double height bays here, which we saw earlier with the red, the sort of rouged kind of glaze on them. So we kind of did some models and did some drawings. This is a simplified elevation of a section of this bit of the pier, and what you're seeing here is the action of the building swaying and the action that has on these tiles. Now, of course, the tiles aren't even that simple. They kind of wrap around and they kind of bond over each other. So it's actually even worse in reality than our simplified kind of model here. So we had to make these 12 millimetre lime mortar joints. And everybody says lime's flexible and it can absorb movement, but it's not silicone. It's brittle. It's crumbly. It just falls to bits. It's not true, but it helps. Apologies to anyone from lime mortar industry here, but so we had to be quite innovative. So what we did, we put each individually supported every single faience piece onto a steel frame, onto steel posts. And we supported these steel posts one for every floor, or for the second and third floor, we had continuous steel posts from spanning 2 floors, and we supported those posts at the bottom, and we fixed them back to the primary structure at the top and at intermediate points, but fixed them back in such a way that they could slide. So effectively what you'd have is I should have had a steel column, but you've got a steel post with all the faience attached to it, and you've got the primary structure behind. So as the primary structure moves, the idea is that the steel post kind of does its own thing, and that the steel post sort of slides across the primary structure, inevitably avoiding the cracking of the faience. We hope it works, because they've gone and built it now. So there's my sketch, and here's a picture at Shaw's of the first faience pieces. Now, is it 116 years? Did you say making faience? Yeah, and and still, you know, I'm sure it's fair to say it was a really challenging project, because these pieces are big, and they're complicated shapes. This is the sort of stalled sill between pier and windowsill, and the first ones were pretty wonky, pretty out of line. But yeah, Eric loves this material, and we understand that it's meant to be a bit wonky. It's meant to be a bit crooked. We saw like Renzo's building earlier, which is too perfect in some people's views. So this was kind of fine within reason, though we did. I think a few went back went in the bin. I think, yeah. But we got there in the end. This is the rouge blushing, and Eric talked about using decals and using transfers, and this is something that, to my knowledge, has not been done in the UK in architectural ceramics by using kind of glazed transfers. But glazed transfer's been around. I think it was Wedgwood invented it in the 1850s as a means of mass producing, decorating highly complex designs on plates. So Shaw's had the problem of trying to get Eric Parry Architect's digital image of this sort of this blush onto a ceramic piece. So the way they kind of came up with doing this with their glaze manufacturer was to screen print onto paper, take a digital image, turn it into a screen print ceramic ink onto paper, soak that, and then slide the ink very carefully onto the pre-fired white glazed piece, and then stick it back in the kiln, and the kind of glaze melts and bonds itself to the piece. Again, it comes back to testing, and Ceram did a load of tests, and everything was fine. It didn't debond, it didn't crack under temperature change. We put it through pretty rigorous tests. We figured that most transfers are dishwasher safe and oven proof as well. So that gave us a bit of a clue as to how it might perform. So we weren't too worried. And then the other thing, of course, was getting Richard Deacon's artwork on. As Eric mentioned, it was very challenging. The piece you see in the middle there is Deacon's original artwork, which is some really vibrant kind of magentas and cobalt blues on watercolour origination, which was scanned and turned into transfers, and they just came out kind of muddied, and this is a really miserable, disappointing day when we saw these, because it was a million miles from what we were hoping for. But again, the guys at Shaw's just pushed on and tried again and again and again, and eventually the final result was fantastic. Another technical challenge with Richard Deacon's artwork, so this is the kind of challenges we have integrating kind of art into facade, was these cornice pieces, and there are 39 variations of these. We took the most complicated one, and this is made out of 3 pieces of faience, which are mortared together and supported on a stainless steel backing frame. Was what happens when the cleaning cradle comes over the top of the building. It's 5 stories up, wind's tearing down Piccadilly, and as so often happens, the cleaning cradle gets blown into the facade, cracks a huge piece of faience off straight over a busy pavement, West End pavement. So we undertook some impact testing, this big 50k bag full of glass beads, which we swung at this cornice piece, and it passed with flying colours, we're pleased to say. This is a mock-up, which is just showing the final sort of one-to-one pieces in a yard in London. And there's Richard Deacon just putting some final touches to his artwork piece. And the building, of course, we've already seen some works of it in construction. As I mentioned, it's always scary seeing what you've drawn and designed yourself, suddenly reality. Thinking, oh, God, does it really work? But yeah, it's all fine. Actually, the first time I saw it was the first day back after Christmas, because the building's been under scaffolding for 18 months. And I cycle down Piccadilly on the way to work every day, so I go straight past it. And first day back, 2nd of January, with a sort of post-Christmas blues, suddenly saw this facade revealed for the first time, which was very exciting but very terrifying as well, because as Eric showed, the cornice was completely covered with white paper. They're actually unveiling it on Wednesday, apparently, at 11 o'clock. But suddenly this cornice we'd put so much work into with all this colour was completely white, and just wondered what on earth had gone wrong. But hopefully nothing's gone on. Hopefully it's not going to peel off as they pull the paper off. But it won't. It'll be there in 200 years as well. And there you can see all the pieces. So kind of it is a skin. It is a delicate, thin facade really, that's kind of moving and responding to the backing structure. But it looks kind of very solid and very monolithic. See the paper peeling away there on the right. And you can kind of see a lot of kind of inconsistencies in the material here, where it kind of twists and moves, and that really does give it life and really does make it a tactile facade. It's from Piccadilly. So really, just to conclude, we've seen that there can be fantastic collaborations when artists are involved with projects, and when really creative, unusual thinking is involved. The whole process needs to be sort of joined up with testing specialists, with consultants like ourselves, engineers like ourselves, with architects, with contractors as well, who have to actually build the thing. But I think we're really just touching the surface now. Since I joined the industry working for Ibstock in 2000, when brick was really unfashionable and really miserable and architects hated it, to now where brick is really fashionable, architectural ceramics are becoming really, really innovative. There's so much more that can be done. I mean, we've seen sort of Fernando's work this morning, and some of the sort of beautiful effects that can be created using ceramics. And I think now is really a really good time for working with artists, but also for architects to work with manufacturers as well. They don't all need to be kind of Crown Estate, £2,500 a square metre ceramic facades. I've worked on projects where we've just taken simple bricks. Like that example it wasn't one of mine, but that example on that poster there was just taking a very simple wire cut brick, breaking it in half and exposing the broken edge of the brick, and they're 25 pence each. But there's so much potential that can be done, just using waste materials and different kind of glazes. So it's a very exciting field, and if anybody has any exciting projects, I'd be delighted to hear from you. Thank you.
Right. Thank you. I've just kind of been thinking really about the idea of the brickwork buildings we've done over many years, really, and their relationship, and questioning them really in terms of, and reflecting on the idea about innovation in our work over that period. These two buildings here are about 4 miles apart from each other in central London, and span about 40 years of our practice. Perhaps if you didn't know, you might think that the building on the right was the new one and the left was the old one. In fact, it's the other way around. This is the last building I've just finished in central London, which is Henrietta Barnett School in Hampstead Garden suburb. But actually what I'm going to talk about really is, through the work of our practice, how a completely, as we see it anyway, a completely sort of consistent set of thinking and philosophy binds those two buildings together. The first building that I did in the practice, or worked on in the practice, which is our first sort of exploration in brickwork, is not so far away either. It's the Mound Stand at Lord's Cricket Ground, where we had to. The challenge was to kind of replace this building you see in the lower part of the screen, and what we found, in a sense, which is exactly like Michael Hopkins' own house in Hampstead, was a modular structure there made of brickwork on the bottom right. And we kind of thought about that, and we took that structure, which was actually, there was a steel frame behind that, so that brickwork wasn't load-bearing. But we used that as a kind of generator for a new building, and the brickwork arches became the modular kind of constructive element that ordered the entire architecture of the new building. So perhaps completely kind of perversely, really, we cut out the steelwork, which at the very top of the structure, which reverted the old arches to actually load-bearing brickwork arches, and then we extended those brickwork arches all the way along the bottom of the building. So they became this kind of ordering, load-bearing base to the building, on which we took then a completely separate structure, which was this new steel structure, which was able to span much greater distances. So on the one hand, you had this arch structure on the bottom, which could contain all the kind of storage and backup facilities. On the top, you had this steel structure which could span much greater distances. It'd be much more appropriate to keeping vision lines onto the cricket pitch. So, you know, we had a facade system that combined completely different attitudes to technology, but importantly for us anyway, which was a sort of theme that has carried on in the office really, is this idea that actually it's less for us. It was less about sort of finding a style and kind of using this brick arches as a kind of a pictorial or stylistic motif, but actually both of those elements, top and bottom, are defined visually by the character of how they're made themselves and how they support structurally the building. And it was that attitude of kind of almost sort of looking back and kind of, just sort of deconstructing what we found. So kind of looking back into history on the one hand to find something new in it, that then took us to this next building, which was, again, a mix of materials from, in this case, brickwork at the end to gunmetal in the middle. This is Bracken House just by St Paul's. The two ends were existing. It was the old Financial Times printing press, and the old printing house was in the middle, which had since moved out to Wapping. And I did a lot of research when we started looking at the history of how the original building by Richardson had been designed, and we found that he'd kind of used this idea of a Baroque palazzo in Turin by Guarini, but he kind of got lost somewhere along the lines in the way that he'd done it. But you can see in that plan there's a kind of two blocks either end and then this curved element in the middle. So we thought, well, actually, if we take that original model and we kind of mirror the central oval bit and make a much bigger oval, we could kind of collage that onto this new project, and we could take Richardson's old brick blocks at either end, which had completely different geometries actually, and we could take a circular geometry, an oval geometry, and put a new building into the middle and stitch together everything, the whole site, with this new circular geometry, with this new oval geometry. Marrying really and taking away his printing works and marrying this idea of the kind of the history of the thing with its kind of together with its kind of reinvention. And certainly in the office at the time we had things like this. This is I'm from Liverpool. These are two buildings from Victorian Liverpool. And I suppose in a way this is an 1860s building on the left by Peter Ellis, an 1880s building on the right. So quite interesting in relation to Henrietta Barnett versus Michael's house. But the one on the right, although it's later, actually feels much less modern because there's an architect there that's kind of playing with brickwork in the sense of a kind of style. An architect on the right, it's not brickwork, but it's not on the left, sorry, much earlier, but trying to sort of rid himself from style and express much more the kind of the lightweight aspect of how that building is constructed. And it's not a sort of uncoincidental that those bay windows on Bracken House have a kind of relationship to those ones in Peter Ellis's building in Liverpool, because it was that model that we were using of this, trying to get this sort of skeletal architecture that expressed how it was made on the facade, which Bracken House did. You know, that facade was a structural facade. And that's been that constant way of sort of looking at history and finding a way through that without falling into this sort of trap of style, which so many, to us, so many kind of brick buildings kind of end up as. History too, in our first really big brick building, helped us to kind of see through that. The building I'm talking about was Glyndebourne Opera House, which we built in the mid-90s. One of the things we looked at with that building right at the beginning was this model of a Bavarian Rococo church, which is, many of them are based on this multiple idea of circular overlapping geometries which make up the sort of primary structure of these churches. We had that idea because we got this problem of making these interlocking volumes at Glyndebourne, which was on the left the backstage, in the middle the stage, and on the right the auditorium. And we took that radial idea to make this actually very modern plan that stitched together all the sort of the main performing and working spaces of the opera house, and then put a ring of accommodation which was much more small scale around the outside, which worked beautifully in terms of creating a buffer zone for the acoustics of the silent, the sort of musical spaces in the centre of the building. But it also allowed us to create an architecture around the outside, which was kind of intended to be much more sensitive to the very precious historic sort of surroundings of this country house. Here's the country house of the Christies, the family that sort of run the opera house on the left, and here's our opera house on the right-hand side. And you can see what we tried to do was create an entirely sort of brick building, but to fit in with that kind of architecture, because it was absolutely sort of one was just feet away from the other. But the brick for us gave us a way of finding a scale to that building that seemed appropriate to be able to create such a large building in such sensitive surroundings, really. And we look now every architect will know this building. It's the Exeter Library by Louis Kahn in America. And we loved this building. We looked at it a lot and used it as a kind of generating an idea for Glyndebourne, really, which was this very simple square library building where Louis Kahn had used load-bearing brickwork on the outside. He'd used these series of load-bearing arches, and just this very clear and legible idea that as the building picks up loads as it comes down the facade from top to bottom, so the brickwork piers go from thin on the top to thick on the bottom, where they pick up the heaviest loads. Everything based on the sort of scale, though, of that load-bearing arch. And so this is, I mean, I see this as a very primitive drawing, really, because for us it was trying to find a language for this new brick architecture, really. But you can see in that this idea of kind of breaking up this big building by these series of individual bays, each bay related to the scale of a dressing room or a wardrobe room. So it had a kind of human and room scale, which the brick arch was able to structurally span over. It's 3.3 meters or something. So gradually we've sort of refined this architecture from what was quite crude in that first drawing to something which was a very simple kind of language on the one hand and very non-innovative in a way, but in a way it was so kind of refined and took this idea of making a load-bearing facade in a very sort of true and legible way that created this kind of modern, crisp architecture, which was sort of historic and modern at the same time. And you can see how, you know, we worked very hard with Arabs actually to create this way that an attic floor came down and sat on a brick wall. That brick wall picked up the loads as it came down, and those piers get bigger as they did in the Louis Kahn building. And then the arches just span from one pier to the other, creating the window openings. And hey presto, you kind of sort that. You sort your entire, with a modular plan, just like in a steel frame building, you get a kind of language that you can, in a very refined way, you can extend all the way around that and apply to the whole of the building. So for us, you know, we all had those sort of textbooks when we went through college, but it was a very different kind of architecture and a very different kind of brick skin than everything else that was going on around at the same time, really, where actually, you know, on that drawing, the skin is really a skin. It's not actually something that goes through the substance of the wall. And for us, that felt that you were missing something in the character of the brick to not do that. Not only that, but you'll make, when you started to make openings in that wall, you could kind of do, at one level it's very liberating because you could sort of do anything you want with a cabinet lintel. But at the same time, you're missing an awful lot about what is the amazing character of a load-bearing brickwork facade. So we put an immense amount of effort into really kind of learning about how to make that load-bearing facade, because nobody was really building large, new load-bearing brick buildings at the time. And we worked very, very hard to make that arch work and to bring it all together so that you could go around a curve, you could go around a straight, and you could go from top to bottom with these different size piers. But you can see we made this very kind of raw building, really, where the brickwork went from inside to outside. We worked very hard to find a brick that we could use throughout. So on the outside, so it's the same brick throughout, so it had the same structural properties. But on the outside, it was sand-faced, and on the inside, we took the sand off. So you could get a different finish inside to outside. But at the same time, the thing had a holistic structural performance to it. And it was interesting to kind of think about at the time, you know, how loads of brick manufacturers and loads of architects were creating buildings where, with kind of funky, in inverted commas, innovative things in brickwork, but they were all based on really what was happening behind that brick skin, rather than actually tackling what the brick could do itself. Whereas what we were doing, these are the arches, the three arches as they go from top, middle, and bottom. Those are the arches those are the brick special arches in the brick manufacturers. In a way, you know, trying to make something very special out of something that's essentially a lot simpler than any of the pieces of architecture that you see on the right. So it went from kind of understanding and finding the right brick to really, you know, because we were kind of doing it from scratch really at this moment in time, to really understanding what's the appropriate bond to build in, and actually kind of go, you know, at a level of brick by brick, understanding how one of those typical bays got made up. And in contrast to my respected last speaker, we found we worked with lime mortar. And we worked with the brick contractors, and they'd never worked. You know, they'd never worked really with lime mortar. They'd only ever worked with cementitious mortar, and it was a fantastic adventure because we got it wrong to start off with, and we didn't even realise about the slaking process where you leave lime mortar to go off, and over 24 hours it changes its consistency, and it becomes more plastic, and in that more plastic mode, you then lay your bricks together, and then actually it did and still does work. Glyndebourne, it has no expansion joints in the entire building, and each mortar joint expands and contracts in a natural way because of the way that the lime mortar doesn't set in the centre of the joint. So it's a sort of beautiful kind of way of looking back at the kind of very basic, primitive processes and traditional process of brickwork to find something that was really hadn't been done, apart from in sort of conservation at the time. But of course, you couldn't make an opera house. You couldn't just with the scale of brick arches. And so what we also had to sort of tackle and think about was, how do you get a brick building to also kind of marry with the idea of making big modern spaces? In Glyndebourne, it was about the auditorium and the backstage spaces. And we looked at buildings like this, which is Berlage in Amsterdam, where obviously in this town hall, he's got a series of masonry arches around the outside, and they're of one scale, but he's got a completely different sort of architecture going on in the space of the main hall. And what he does so beautifully is the way he creates a kind of language of how those two scales and two different sorts of construction actually meet, you know, in all these kind of amazing tops of these brick columns and so forth. And that, you know, in a way, it becomes the story and the language of the architecture. And if you found me lurking around any central London train stations, you'd be much more likely to find me lurking around the back and in the train and in the over the platforms than, you know, staring at the wonderful Gothic frontages. Because again, you know, these sort of our office is right by Marylebone. It's a you know, absolutely beautiful kind of example of how you take a sort of steel structure and then you kind of marry that with a kind of masonry or a brick structure, and that kind of idea of how you make those joints actually gives you a massive character to the way you create an architecture in the building. And in a really sort of simple way, back at Glyndebourne then we had, you know, the brick arches which were of one scale around the outside, but then this need to create a concrete architecture and a steel architecture on the inside. And we just, you know, kind of enjoyed in this almost primitive way, really, how, you know, a precast beam can mould itself just like perhaps an Elizabethan timber beam to sort of go from one profile that picks up the larger elements from left to right to something that can quietly fit into a modular load-bearing brick facade as it passes and transfers the load from the floor into the wall. So a whole character to that architecture, which is about its structure rather than its style, really. Of course, Glyndebourne was an amazing thing because it was all built in load-bearing brickwork, but it was evident, you know, it was a very special project, and you know, loads of those weren't going to come along, really. So we did have to address and think about, you know, what would we do if we had to build a building out of cavity brickwork? And we sort of looked at all these sort of diagrams and typical ways of building cavity walls. And actually, when you look at it, you see the brickwork on the outside, but what you also notice is the huge amount of material that's on the inside of the wall, which is put into the wall to kind of make the brick look like it's doing a job that it's not really doing. And there's a weird sort of thing going on there, that there's all this architecture that no one ever really sees in cavity brick buildings. You know, the same with you know, kind of channels that take, you know, to support plates that then support, you know, whole panels, floor panels of brickwork which go from story to story. And in a way, for us, the excitement's all on the inside and not on the outside. So we wanted to find a way of beginning to think about that. And when you walk around London, I mean, you see, obviously, everybody sees these every day. And it was that idea of kind of a brickwork, because in a way a cavity wall is this, which is, it's a kind of a brickwork wall that's not really able to do what it needs to do. It needs help. It's a kind of failing structure inherently, because it needs all those bits of metalwork. And in a much more simple and poetic way, maybe, the kind of failing Victorian brickwork facade that needs tying back into the timber structure is a much nicer kind of expression of that failing, in this case, failing structure, than perhaps all of that stuff that's going on behind the skin. we also looked at this work of Viollet-le-Duc, who's a Parisian architect in the 19th century. And this is an interesting language, you know, which takes not just a masonry brickwork structure, but a sort of takes masonry to make a facade, but then uses another sort of architecture, which is steel and stone, to support that architecture in a kind of mutual way. And there's a whole really nice kind of thing that's going on about how you go from brick on the one hand to the spans of those steel props that support that ground floor. And this is a very modest little building in North London, which is a old people's home. And we took that kind of idea and we applied it to this building, where the big communal spaces are on the ground floor. So they do have load-bearing brick piers, which are down here. But they're at sort of 8-metre centres that allow these bigger spaces to be formed. And then the precast architecture takes the load from above and pushes it onto, takes it onto those load-bearing piers. But then, amazingly for us, actually, you know, you could support 3 stories of cavity brickwork on these really quite slender ribbon of steel trusses, and take all that skin architecture and take it back into the ground. So that was our version, really, of sort of trying to make a cavity wall brickwork building be a little bit more honest about what the brick was doing. And then much more recently, in the last 5 or 6 years, we took a plane ride. We were lucky enough to get asked by Rice University in Texas, in Houston. And it was a real flight into the unknown, actually. They have an amazing campus, which is now about 100 years old, which is built entirely of brick, entirely of the same brick from the same brickworks, actually, which gives it incredible consistency. They'd come over, they'd seen Glyndebourne, they knew of our brick architecture. So it was a bit like the Rolling Stones kind of going over and bringing blues back to the UK. We kind of flew out there to take sort of brickwork and think of brickwork here and take that out to the USA. 100 years ago, they'd done actually the opposite. They were out in the kind of marshes of Texas thinking about what is an appropriate architecture, and they'd come over and done a tour of Europe, and they went to southern Italy and looked at Byzantine architecture. And they decided, though, that the hot weather made for kind of lazy intellectual rigour in the Byzantine architecture of Italy. They went to northern Europe and looked at the Gothic architecture and decided that the cold climate made for a much more rigorous, formal architecture. They decided that then they'd make the best of the whole of Europe and combine a kind of Byzantine architecture with a kind of northern European formal rigour. And this is what came out of it. So our kind of question to us was, well, how do we create a new brick architecture, take one back over there that doesn't just kind of deal with all this in a relation of in a way which is stylistic. They have a lot, as I say, all their brick buildings are all made from one brickwork, St. Joe's in just outside New Orleans. A lot of it quite plain, a lot of it very non-expressive. What we did was we made cross-wall, these are residential college buildings. So we used a sort of the brickwork architecture. It was really modest, actually, on the outside. For anything that had a big span, we used a different sort of structure altogether, timber and steel. But we made this very modest kind of, it was made from lime mortar as well, actually, which was completely radical for Texas. But we made a full skin of brickwork outside wall, with this sort of residential scale precast mullion system for the windows, which gave them a very modular buildings on the one hand, but buildings that were sort of expressive of what was inside them, and very appropriate for and fitted into their context as both modern on the one hand, but respecting their historic precedent on the other. We got a second project there that had to be built much quicker, so we had to build that out of non-load-bearing cavity walls. And in the same way as we'd done at Jewish Care in London, we took that realization that we had to break a cavity wall every few feet, every 18 feet with an expansion joint. So we started to make this architecture out of bays. We expressed in those bays, they got coordinated with how the rainwater came down from the ground and with how the ties, these are the, you can't quite see them, but these are the ties that tie the main brickwork back to the concrete frame. So a simple architecture, but one where the masonry is still trying to express in a quiet way, how it's performing and how it's being built. And then finally, just right back from home and back onto the first slide, Hampstead Garden Suburb, which is just up the road, which is an incredibly precious kind of garden suburb, hardly altered since the very beginning. We had to build new buildings right next to Lutchins, who'd built this main school building. How to make then a kind of innovative modern building that somehow respected this historic environment where basically no new buildings had been built since the centre of the suburb since it began. The other problem was the new buildings were much smaller than the grand scale of the Lutchins original. But what we did find was this idea of the scale of his primary sort of architectural piers on his facade, and we took those and we kind of borrowed them and made an architecture kind of a little bit all the way like Lord's so many years ago now, but made a new architecture which actually defined married the scale of the two together, but in a completely different way. So we made these load-bearing piers. We also borrowed the scale of his roofs. So we made these new buildings out of new wings, the same scale as his. But the roof then sits on a series of load-bearing piers. That forms a kind of primary order, and then around that primary order, we then sort of played various other secondary games. So here's the simple load-bearing pier, picks up the roof. There's a precast ring beam at the top. It then picks up the floor in the middle, the first floor. The pier gets bigger, the brick arch spans, and the window openings are just naturally formed. And then we took that architecture, and as it turned around onto the garden side of the school, we then made it into arcades and piers. We spanned a kind of upper walkway, which fitted by these little kind of pad stones into the wall, creating a kind of a new architecture, which really was difficult to do when everybody expected it to be just a kind of completely pastiche historical building. So in that way, I feel that it's an interesting story that connects 40 years of work, really, in a very consistent way about the way that brickwork or steel or any material that we work in, if you really embrace the character and the nature of the material, then you can create an architecture which is based around that rather than something which is kind of implanted upon it, really. And I don't know where we'll go next. At the moment, we are building some very tall residential, designing some very tall residential buildings in London, which I know they definitely won't be load-bearing brick. But I'm very excited about really the idea that in a way it's such an ancient kind of material that as you look back, you're constantly inspired about how it's been used, and it seems to me to offer endless scope for innovation and creativity, whether it's to do with the environment, like these breathing barns in Italy, whether it's 2nd century BC in Iraq, these amazing remnants of brickwork arches, or is it like the part of that building on the left, which is an amazing composition in itself. You take off all those brick arches, that is an incredibly sort of modern piece of design, really. Or is it like this at the Pergamon Museum in Berlin, which is a fantastic gateway, where on the one hand it's a piece of brick, but on the other hand that each brick is defined, whereas the brick together is creating something completely different. I love it, and I think we're gonna carry on innovating and carry on thinking about how to use brick in all our work that we carry on doing. Thank you.
I'm the last travelling brickmaker in the United Kingdom. That is, traditionally, brickmakers travelled from... Can you hear me all right on that? Is it okay? Let's just see. Yeah, you can hear me, can't you? Brickmakers travelled from place to place, probably from about the 15th century or probably a little bit before in this country. And gradually, as technology improved and everything else, brickmakers started to get less and less. Now, travelling brickmakers. The major change in the industry is 1666, the Great Fire of London. So, after that, the brickmakers, there are less of them, and mechanised brickmaking came in the 1830s. So, what I do is I'm the last one. When I've finished, that's it, there's no more. As you can see on the picture here, this is in my hand workshop, and this is where I make new moulds, some specialist stuff. You'll see there's plaster moulds behind there because I also make architectural terracotta, and I also make faience. I don't do very much of it now. I used to make chimney pots, but I don't do that anymore. There's just not the demand. But you can see behind me there some bricks. This picture is taken by a chap called Steve Kenwood. He's been doing quite a lot of photographs of dying trades in this country. You can see in my hand there I've got a roofing tile mould there. And for those members of the BDA who also make roofing tiles, they probably don't see those very often in their works either. On the edge of the picture here, you can see that I've been making some valley tiles, and I still do those as well. So what I'm doing is I'm still doing all those processes that a large brickworks used to do, but now that's all done by machine. I'm still making them by hand. So what I've done is I've brought with me my apron. It's a fantastic lambskin apron. I tell you what, it doesn't half keep your clothes clean. And when I first had this apron, I was a lot bigger than I am now. I was nearly 19 stone, and this apron used to just about go round me. Now, it's actually quite a nice fit. So what we've got here, this is actually a project I did at the end of last year, and this is for... There's been a massive restoration in Broseley in Shropshire of their 1870s cemetery. It was a purpose-built cemetery, and the local brick and tile manufacturers, and there were a lot in Broseley, around about 60, and what they did was they supplied, each work supplied a little bit towards the final project. What's happened is, over the years, is bits have fallen off, and on the cemetery chapel, which the floor of which is actually what's left of the Foreign and Commonwealth Office, the company that did it, Craven Dunnell and Company, provided the entire floor, which is inlaid in caustics, polychrome encaustics, and they had some leftovers, and so they floored the cemetery chapel with it. The chapel building was built by the Broseley Brick and Tile Works, Broseley Brick and Tileries, and they put all the buildings up, and these were provided by William Exley and Sons, and they specialised in these large ceramics for the tops of buildings. So what we had to do was copy it. Now, if I can give you an idea, that whole thing stands this tall, okay? And because of its weight, and because of the way it's got to sit on the top of the roof, what we had to do is to make a new collar and the top separately. And the top has been made in 2 halves. I was going to bring it today, but to be quite honest, it's going to take me 4 hours to make it, so we haven't got enough time for that. So what it is, it's been pressed. What I've had to do is to take the original, copy it, enlarge it by hand, 10%, cut it completely new as a new piece from a piece of clay, take a plaster of Paris mould of that, and calculate the shrinkage, so that when it goes on the roof, when it's fired and goes on the roof, it'll be a perfect match. Now, by copying it, what I've done is I've made a mould of it in 1 half. It's pressed in 2 halves and luted together, joined together to make the full pot. So that's that there. So that's that one there. So while we're doing that, I'm just going to get this little lot ready. This is a project we've been doing over the last 2 years for Polesworth Abbey near Tamworth. Each brick weighs between 18 and 22 kilos. When it's first made, it's 24 kilos thick. The brick is moulded in a mould upside down and hammered in, pressed into shape into the mould, and then the mould is then taken and laid on the floor and turned upside down and then taken apart. So each brick takes around about 20 minutes to make. We had to make 50 of those, and they were to replace 50 that were stolen about 20 years ago. And the English Heritage said that they tried around lots of brickmakers to get them to be made, but they all laughed at them, and they only wanted 50. What I'm just doing here is I'm just using a little bit of oil, and I'm just oiling up. This is the brick I'm going to make, and it's a... this one here is an Elizabethan chimney brick, so it's a chimney-facing brick. So you can see it's on a... probably see it there, it's on a radius. Now, this was used for a lovely little memorial that's going to be unveiled fairly soon for one of the Red Arrows pilots who was killed in an accident very recently. And so the original mould fell to pieces, so my mould makers made me a brand new mould. It's a treat. So I'm just going to put that lid on. That's, by the way, is the Polesworth bricks when they were set in place. The ones that we made are the ones on the left and one or two on the right. But we couldn't tell them apart. Once the stonemason were put them in place, we went right the way down them trying to find which ones we'd done. We couldn't tell. So the process that I use is stiff mud. In other words, the clay is very, very lumpy. It's not like a lot of brick makers where they roll the clay into sand and then drop it into the mould. So this takes a little bit of work just to get it into the mould. Now, I haven't bothered to bring a lot of my bats with me because they're really heavy, and I'll probably splash everybody with little lumps of clay. So the whole idea here is to beat the clay into the mould and get it to fill up. Brickmaking tools are very, very basic. There's nothing really fancy in this. This little thing here, a rammer, just to push the clay in. The mould is in a couple of halves here, so I'll just put that in there. So this is another set of bricks that we've done for a client near Wolverhampton, where he insisted on the bricks being over the lintel, not being split. So in other words, as long bricks. And he also insisted that he didn't want them sawn. So I had to actually make the bricks with a taper on them. The taper is the same over the whole arch, but they vary in lengths, which means I had to make a cutting template as well, and lay each brick on the cutting template and then cut it to fit. It's an absolute nightmare, complete nightmare. I can tell you we had to do 2 arches. The second arch, the bricklayer laid them upside down, the whole lot over the arch. Now, how did he do that? He actually put them in upside down, so he had like lines, nothing fitted, and then he split the centre brick to make it fit and said that I'd made poor quality bricks. Now, to do it, he would have to have split it with a cold chisel and hope for the best. And the client said to me, "Would you have a look at it?" I said, "Yes, certainly." And his wife said, the client's wife said to me, the bricklayer says that the drawing wasn't right. And I said, "Well, he laid the other arch okay." And they were all right, and the bricks were made at the same time. And I said, "So is he blaming the person who did the drawing?" And they said, "Yes." I said, "That's the client. It's your husband. He's an engineer." I said, "That's going to be interesting." So we're waiting to see. I've got to remake them. This one here, you can see on this arch here, on this is a patio, and that's for another client near Wolverhampton. We've made 2 patios for them. This was entirely made in our work. So what we did was we made all the bricks, laid them out, and cut each one to fit the client's design. So that's entirely, not one of those bricks is the same, except for just at the front there, where they're the same size. But that included making the cushion bricks just on the side here. This cushion edge is entirely made from a plain brick, and each one carved to fit the final design. We also made the plinth bricks for it from a different clay, and also a load of rope edges as well. So it's quite a nice little order. So what I've done is, while I've been yakking away, I've pressed the brick out, and you can see that part there. I've now got to mark it. So this is my stamp. So I'm just going to pop that in there. That just gives it a bit of body. I've got to stab it. And this is so that when the brick is drying, it allows a certain amount of the moisture out nice and evenly. When the brick is fired, the heat will penetrate right into the clay and make sure it's absolutely cooked all the way through. There's nothing worse than blackwalling bricks, that is, but leaving it with a damp centre to them. Everything's fine, and then the first frost and they're lost. And then I have to make them again. So that's fine. Now all I've got to do is get that out of that mould, and that's done very simply, like this. So there's no banging, no clattering. It's not needed. And if I just, what I'm going to do is I'm going to put this here, because I've got to do the next bit on the table. So I don't know what that looks like. It's probably vile. Let's just have a little look. Oh, that's fine. So what I've done is I'll just polish that up. We didn't see that, did we? A little crack. Whoops. So what I've now got is a lovely... I've got a little small plaster mould here, which is of a flower. I'm just turning for our man here. So it's just of a sort of a rose, a Tudor rose. And what I'm going to do is I've got to apply it to the brick. So let's put a bit of clay in there. These bricks you can see on the display there. Those ones I've made replacement bricks for the over the top of the arch, and that was on Restoration Man last year, the television programme. And you can see that it's a pretty damn good match there on that. So what I've done is I've pressed a rose out from that. Now just with a wire, I'm just going to cut that off the face. And then I'm just going to, all I'm doing is I'm just nicking the face. So the oil, the problem is the oil will act as a barrier. So I just want to disturb it a bit. It's where brickmaking comes into the land of sculpture. I've just got to... Let's pull that up. Now what I'd normally do is, at this point, is to make the brick and it would be allowed to dry. Leave it to dry just in the warm for about 4 hours, 5 hours, and then I can cut it. But what I'm going to do is I'm going to speed the job up. Obviously, this isn't going on a building. Now, in case you're wondering how I know what taper to cut on that is, I've made so many of these, it's imprinted in my brain what the taper is on that. So that would be the rough cut. So the brick would be finished like that. It would be left to dry then for about 2 days. And then what I would do is would carve other decoration into it. So in other words, at the moment it's just a flower on the brick. When the next brick is in line, the flute comes up in line and the next flower sits about here. And then you'd have a branch carved into it that would run up to the flower. So in other words, you've got a plain flute and then you've got flowers and branches running across it. If you see that in the whole chimney, it makes the chimney look as though it's alive, almost like a tree or a huge branch, whatever. And with the traditional brickmakers, that was the way they did it. They didn't use moulds. It was much quicker to do it that way because you'd have that pretty well dry in 2 days. Not dry enough to fire, but dry enough to store away and everything else. When we make stuff, we don't have any forced dryers. Every brick is made and then put out to dry in the open. So I have to hope it doesn't rain. So this is another one we've done here. This is for a chimney pot, Elizabethan chimney pot, and you can actually see, if I just point this out, you can actually see the flutes there coming up there. This is a plain brick here, and then these have just been put in line. It's all balanced, that's why it's been photographed like that. And these various components here, all different to match the very top there. So it'd be like a rope running around the top, just to finish it off. And there it is. So that gives you an idea of the sort of things I do. Any questions?
And I think we've heard some really, really fascinating speakers today. I mean, they've been a wide range from kind of things that we're interested in the commercial side to the philosophy of design to artistic integrity. And I think it's invidious to mention anybody at all. We've actually seen a brick being made. But I think you'll agree that there's been something in here that will have interested anybody. But I think one of the messages that I would like to give you, I think innovation requires working with other people. And I can assure you that many of our brick manufacturers, many of the artists, many of the engineers and architects we've seen today, are really, it's really a partnership. And I would suggest if you wish to make your building innovative, the best way of doing that is actually to find a brick maker and work with them to produce something very special for your building. And you know, there's an awful lot of innovation possible in brick. Even within a standard brick, there are 60 bonds possible. So to us who are brick nuts, you know, we're very, very enthusiastic about it. It's always slightly depressing to see the constant stretcher bond which is used, and it's so interesting to see different and varied things. The other thing is that bricks really are a very tactile thing. And it's not like cladding, which is made by somebody elsewhere in a factory with which you had minimal requirements. I remember the first cladding building that I did, because I am an architect, and the guy arrived with 300 drawings, and I just felt I'd totally lost control of the building process. And it actually wasn't my building. It was a man far away in a factory I didn't know who detailed up the building for me. With bricks, it's very, very different. It is a partnership. It's a partnership between the designer, between the brickmaker, and most importantly as well, the person who actually builds the bricks on site. And it's actually possible for a good bricklayer to make a bad brick look good. And we actually completely depend upon the bricklayer to actually make our design become a reality. Today, this year's recipient is a very fine bricklayer. Sean Fawcett comes from Blackpool and the Fylde College, and he's absolutely exemplary. He has won the gold medal from the Guild of Bricklayers, which is a very, very stiff competition. It goes through regional heats and finishes with a 6-hour practical examination. Not only does it include a practical examination, it requires a full understanding of architectural drawings and be able to solve quite complex problems. So Sean is actually very exemplary. He's also a young man, and the future, of course, is in the hands of the young. And we at the BDA are very glad to promote good workmanship, and of course Sean is actually quite exemplary. So I wonder, Sean, could I ask you to come up and receive the BDA trowel? Thank you very much. So please drop your feedback forms into it. I'd like to ask thank all the speakers today. I would like to also thank our members for their support for today. But I would personally particularly like to thank the staff of the BDA for all the tremendous hard work that they've done in putting this day on. And they're also very, very much brick advocates. So. And thank you for all being here. So thank you very much indeed.